Caesar, this one is working, so we just need
something
audio is not.
the output speakers.
It should go to like room, I guess. One, two, three, 1, 2, 3. 1, 2, 3, 1, 2, 3. 1, 2, 3. 1, 2, 3. Just this one. Okay. Still doing something, right? I don't know. 1, 2, 3, 1, 2, 3 now. It's kind of working, right? It's not very loud.
Αντώνη, ακούς πίσω που μιλάει ο Μαξίμ. Ακούγεται πίσω. Εδώ.
1, 2, 3, 1, 2, 3.
Όχι, Let me call the guy. The Maxim output is only here. On the
One, two, three, 1, 2, 3.
I called the guy to come.
Yeah, I think we got audio, some sorts of audio.
Yeah, but only here is working the speaker, not outside.
Maybe there is some button somewhere.
I will ask the guy to come.
Okay.
No, we don't have the speaker.
Yeah, it's somehow just that small box in the corner. Yeah, but it's okay.
And you're not recording anymore today, right?
We can. Is there any? You don't want to?
You need to pay something.
It's not connecting now. The same network. Same wireless. Yeah. It's not connected now. What about training? I don't need too much bandwidth. I can just use free Wi-Fi.
You have the same problem like yesterday? Which one is the good one? OpenSIPS. Maxim, do you want to stream or something?
Again?
Do you want to stream or do something?
Yeah, I'm trying to hook myself up.
So you will stream something, okay?
Yeah, it's streaming already.
Okay. Έχει φτιάξει κάποια μποξάκια εδώ στο κλάστερ, κάτι αγοράζει. Πάνω σε αυτό,
You guys have another network cable?
I have a long one.
Yeah.
Everyone awake, alive, check pulse. There's some aspirin.
All right. Hello. Hey guys. Sorry, we're a little bit late on setting up, and I have to admit I saw that I'm doing it tomorrow, so did not much have anything prepared. But what we wanted to show a little bit of development of latest version of RTP proxy. We did recently committed some changes to improve video support. Well, not really to improve video support, but essentially from the beginning of the project.
Ακούγεται μόνο από μπροστά δεξιά από το speaker της συσκευής.
Check. Check. 1, 2, 3, 1, 2, 3. It's good?
Another guy will come.
Okay.
The speakers at the bottom.
Guys, for everyone. Okay. So basically, from the beginning of the project, the code was designed to handle audio only. So as one of the original design ideas, we had the limitation of how many packets. Not here. Okay. It's good? No. Okay, so we'll wait a little. I'll try. Not good at yelling. But
For 5 minutes until he comes.
yeah, the guy will fix it in 5 minutes, so you can just wait, I guess. I can set up a little bit here. So
You're dropping too?
Yeah.
You got me. I want something. Stuff. I'm just trying to figure out where your gaps are. I mean, so you understand, Amy, you understand. You understand of course specific things. It's a great dialogue, right? Transaction. You understand transactions and dialogues. Okay. So, okay, so there's transactions and dialogues. You understand all of this response.
Okay, Dan is coming.
So what time do I have to start? I think I need a...
Got a cable. And there is a network.
Do you see anything? No, huh? Let me try, maybe it will wake up, because I think the...
Our signal is here.
Yes? Yeah. Okay. So now, you see normal signal, no?
Checkpoint. If you have any other big problems, send me to Athens. I can solve them.
Perfect. Okay. So, good morning, guys. Can you hear me? So we can now finally start. Like every live demo, I said I'll be smarter and I'll use a new tool, and of course it didn't work. Maybe we need to, for them to. So we can start, right? No.
Shut up!
Okay. So I said today morning I can show you how you can secure your traffic in a different way that you are used to. So from the billing side. If you remember, on Vasilios' talk on, I think it was on first day, on Tuesday, he told us that he's using CG rates also to store the user detail, so you can practically even store your user passwords, so not only authorize your calls like from the billing, like how many seconds a call can last, but you can store additional details like mangling the user data, for example, completely rewriting his phone number, what he dials, into a blacklisted or maybe a call center number, contact number, so you can control all his behavior. So you will have multiple options to do that from CG rate side. So one I can think of is storing the user password, and then you retrieve it while you are setting up the call, or even with the register. You can retrieve the password via additional parameters which CG rate sends back to OpenSIPS, and then use the standard functions of OpenSIPS with this password which you have retrieved from CG rates. That's one layer of security which you can do. The second, I told you can mangle the destination number, so you can completely rewrite that. The third would be in case of stir shaken, so you can authenticate the caller and callee via stir shaken. So that's another layer of control which you can do in this collaboration of CGRates OpenSIPS, although OpenSIPS itself can do stir shaken. Then another layer, it's routing. So you can, via the routing module, you can again rewrite the destination or route towards an IVR server. So you have multiple levels of control. Then there is resource management. So if the user doesn't have enough channels, again, it's another layer of controlling. And there are also triggers. So if he's dialing like unwanted destination, blacklisted numbers, again, you can control that too. So what I'm about to show you today is how you interact between CGRates and OpenSIPS, and we try to understand a bit the message exchange. So you can see that everything becomes transparent. It's not anymore a black box. It's really just APIs which are executed between CGRates and OpenSIPS. So I wanted to go through the whole installation myself, but I already cut some time from my own. So I will use the installation which I did yesterday. So believe me, I did start from a fresh VM yesterday when I was preparing this tutorial. So these are all the commands I have executed, and I'll go through them one by one, so I explain you what you have to do in order to install CGRates with OpenSIPS and make them work together. So in the first phase, I have installed the Redis server, which CGRates uses as a database, and MariaDB as storage for example, for CDRs. MariaDB is also used by OpenSIPS to store the gateways for the routing. I'll also show you how you can do routing as a combination between CGRates and OpenSIPS. So you store the gateways and the carriers in OpenSIPS and use the logic of routing from CGRates. This is also possible, and I'll show you today how to do that. Then, in order to install CGRates, it's as simple as OpenSIPS. We have, by the way, everything what I'm doing today is on Debian 11. So we have packaged for Debian. We store that in our, we host that in our own repository. So you will, all these steps are, you can find on the read the docs of CGRates. So here in the installation section, you can have how to install it via from Debian, how to install it manually. So you can also get, because we have a package archive. So if you want to go on older packages, you can find quite some archive inside there. So you have for both branches, which is the master, we call it nightly, and 0.10, which is the stable release. The latest 1.0 is not yet ready for you to test much. It's more for us, the developers. So you will go and grab a package. You have, again, also on Red Hat, we do have installation, and also you can use manual installation out of sources if you are a Go developer. Also, you can create your own Debian, so it's all documented there. Now, coming back, so after you get your CGRates installed with these two commands, you will go and copy the configuration. So we have a tutorial related to OpenSIPS, and you will find this on a path. I can also show you where on the machine itself. tutorial OpenSIPS. So you can find here both configurations for CG rates and OpenSIPS. So they should be fairly plug and play. And I tested today, and they still work. Then after copying the configuration, we hold the configuration like all the softwares in etc CG rates and then cgrates.json. So it's just one file, etc CG rates, and we'll go through that in few moments. And after copying the configuration, you will go then and set up your database schema. So we provide a script for that too. It's again on this path, and it's also available through installing, so you don't have to download anything extra. And this will set up the schema as well as the user used by CG rates. I'm using sudo, so I don't have to remember my password, my root password of MariaDB. Then with the CGR migrator, we will set the versions. You know this also from OpenSIPS. You have a table versions in OpenSIPS. Something similar we have in CG rates. It's just that we don't have it just on MySQL side. We have it also on Redis side. And our versions are not only for the schema. They are more for the objects, because we all work with objects. So each object will have its own version, and through this setting of the versions, we will detect if you are using the correct data pairing between data and the engine. So that's the purpose of this CGR migrator. That's the tool which understands how to migrate and if there is any need of migration. So that's all it takes to get CG rates installed. Normally it's even faster than I explain it. Then the next thing, which I'm sure you should be the master guys on this, it's about installing OpenSIPS. So for that I have chosen the 3.3, which should be the latest stable OpenSIPS. And I have just executed this command, installing the core OpenSIPS, then installing the OpenSIPS CG rates module, then MySQL connector for interacting with MariaDB. OpenSIPS auth modules, if you want to do this processing, which I told you about, that you can send the password back from CG rates, so you can then use the auth functions with the data coming from there. And OpenSIPS CLI, I needed it in order to set up the DB schema of OpenSIPS. So these are the modules which I installed. Pretty basic installation of OpenSIPS as well. Then I had to go and copy the OpenSIPS custom configuration, which works with CG rates. I'll go through that as well. And then I had to, I did some modification here, but this is already, I have pushed it, because we were just using previously UDP listener, and 3.3 only works if you put both UDP and TCP, so you need also a TCP listener. But as far as I could understand, this was fixed in current master of OpenSIPS. But we have fixed that, so this step is not needed anymore. So after that, I went and set up the database in OpenSIPS. Again, I use sudo because of the root password of MariaDB. And I didn't need any extra schema, because the database is needed just for the routing part, for LCR. So, and then I have inserted this information inside, added 2 gateways, and because we have set up 2 carriers in CG rates, And so I did 2 carriers and 2 gateways into these tables. So that was all I had to do on OpenSIPS side. The only thing which must match between CG rates and OpenSIPS is carrier ID. In this case, it's route 1 and route 2, and this you will set in CG rates. I'll show you that as well. And the part which didn't really work as smooth as I thought it will, I have installed SIP tester in order to have termination for my calls. So in server mode, SIP-P is terminating my calls just to see that it works. So instead of sending with the carrier route to my own user agent, I have used like almost a real termination. So this is all I have done on the server, and I'll walk you now through the configurations. So first, it's what it should be most common to you. It should be the OpenSIPS configuration. It's you are listening to TCP and UDP sockets. All this should be fairly plug and play. The only thing which might be new to you would be the CG rates module. So in order to use it, OpenSIPS with CG rates, you need to load CG rates module, and the only configuration which you need to do is the binding, the IP address of CG rates. And this is the place where OpenSIPS will contact CG rates with RPC calls, JSON RPC calls. Regarding these JSON RPC calls, it's some sort of non-standard JSON RPC because it's bidirectional JSON RPC. Normally, the standard is one way, but we have used on the same socket 2 ways. So your JSON RPC client will be a client when it sends the request, and a server when CG rates sends the request to your client. So this is the difference, and this is what it makes possible to disconnect live calls from CG rate side over the same socket. So we don't have to configure one connection from OpenSIPS to CG rates and another connection from CG rates back. We will learn the connection which comes inside, and we will use the same socket to also disconnect the call. So I consider this not a breaking of the standard, but an extension of the standard, because JSON RPC is standard, but this it's a enhancement. Let's call it JSON RPC.3 because they already have the 2, and it works great. You are loading the module MySQL for derouting module, and all you have to do in derouting again, it's this binding towards the database. So the first thing, other than what is pretty common configuration for an OpenSIPS server, is that after actually there are two things. One is the authorization. So before letting the call be routed through your OpenSIPS server, you will authorize it with CG rates. That's also the phase when you can retrieve the password, you can alter the phone number, you can redirect, you can populate the data as you will see in the AVPs. So that's what this function does. So you set up, you have the opportunity to also fine-tune the requests which are going to the CG rates by selecting which modules you want to use in CG rates, and also pass some parameters. The optional things are enabling the modules, and non-optional, like these two, are simply adding something like AVPs. Perfect. So once you have set up these options and populating the CGR variable, you will send asynchronously the authorization to CGRates and then resume it in another route. So this makes everything performant because it's asynchronous. So you will resume in another process. You will not block your process because you still have an external network connection from OpenSIPS to another system, which is CGRates, which doing it asynchronously is a wise thing. In the resume, we will be first checking the response code. So we make sure that the response code was not error. If it's an error, then we can reply to the originator that he's forbidden or the CGRates ought to fail. This will be the case if your CGRate server is down. So this is the place where you secure your traffic. You can simply ignore the fact that you have no connection to CGRates and let the call go through. So, but that's the decision. This is why I told you CGRates is non-intrusive. It's still within your power whether you want to use it or not. So here we have chosen to secure the server. So if there are any problems with communication with CGRates, the call will be forbidden. Then in the next, that's also a trick because CGRates will answer back some data, will share some data back with OpenSIPS, and this is the place where we encapsulate the data which, actually decapsulate the data which was coming from CGRates and insert it as, make it available as AVPs within OpenSIPS. So from this moment, it gives you all the power you need and you have the data like you always had it in OpenSIPS. So everything what CGRates sends you, you get it as AVPs inside your script. So now you can play and take any decisions like you used to do with your own AVPs in OpenSIPS. And then you are enabling here the accounting within this. You need a dialog for that. And then we are checking if we have a route digest, which means go and process this request with the routing module of OpenSIPS. And if not, if there was no routing retrieved, which means we didn't select it previously, because remember in the options we have selected the route module. If we don't have this information, just send it out. Most probably, this is what you do when you want to call from one user to another without going through routing. This will mark just some debug. This will mark that authorization was okay with CGRates. Then you will load the information which CGRates passes back into carrier's AVP. So you make it available to the derouting module of OpenSIPS. And you are resetting the index so you know that you are starting from fresh. And then you do route to carriers. And this route to carriers, it should be something which it's, I think, pretty common to what you do. You use route to carrier function in OpenSIPS. And the things then are magically working as you are used to. I'm specifying this because I'm not anymore an OpenSIPS administrator, so you should be more familiar with this than I am these days. So again, also with failover, so you can make multiple carriers and retrieve these multiple carriers from CGRates. So that's OpenSIPS side. Now we quickly also look at CGRate side. So on CGRate side, we select the socket where we listen. If you saw on the OpenSIPS side, we are connecting to CGRates to the port 2014. You need to remember this because when you look at the listen ports, this is 12 and 13. So 2014, it's a special port. It's not the standard thing available widely. It's a special port available in a single module, which is the sessions. So you see, the sessions is the one which extra listens to a bidirectional connection, which means these APIs, only the sessions APIs are available for bidirectional connectivity. All the rest are not. So if you try to the port 2014 to send normal APIs, you'll get that the APIs are not recognized because these APIs are only available for bidirectional connectivity. So that's where we listen. Then the connectivity to MySQL to StoreDB, because we use two different databases. One we call DataDB, which is operational data like accounts and all these profiles and stuff. And the second, it's the StoreDB, which is, in our case, MariaDB. And we are just setting a password. All the others are inherited from defaults. You see just few parameters here because all the rest are coming from a bigger pictures, which are config defaults in CGRates, and these ones are pretty extensive. So if you look this configuration, it has quite some number of lines. So it's almost 1,250 lines of configuration. But the good news is that you are altering only what you need to be different from default. So if we look at, for example, StoreDB, you already set the DB type to MySQL, the host to localhost. So we are inheriting all these settings from default. This is why you don't see the IP address here. You just see the password, because the password normally it's empty by default. So we are overwriting it, and we set the password to connect to database. So this is why you see only few options in this file. What you will have to do is to go through this file and maybe read the comments, because it tells you all what you can do inside. So yeah, this is about configuration. If we look, because the closest module OpenSIPS works with is in CGRates is sessions. If we look, we enable here, then we listen to the port where OpenSIPS send the request, and then we contact, here we set the binding with other modules. Because if you remember, let me see if I can, yes, I can show you. These are all the modules of CGRates, and this is the place where OpenSIPS will connect from outside. This is where it will land inside, so all the RPC connections will be sent here, and from here we set bindings through these connections. So we will decide whether we can go in process, which means internal, or out of process, with which you can see that it's using some local host abbreviation, so we will be able to sniff this traffic. This is the reason I put it over network, so we can also sniff the traffic and check what's going on deeper. So this is about the connection. Then you see we have a channel synchronization interval. And what is this? Is sometimes, you know, like bugs in software, it can happen that the channels will be stale in CGRates, because we are not really familiar, unless someone tells us, with what's going on in OpenSIPS. So if for some reason you didn't do a proper loose route, or you didn't create the dialog proper, or whatever, we don't receive the buy. We will keep, and you have a prepaid call, which we debit every 2 seconds or 5 seconds or whatever. We will debit this until your balance is completely depleted. So in order to prevent this, we have a security mechanism, which allows us to synchronize with OpenSIPS. So we will query OpenSIPS from time to time and ask about active channels. So we detect the channels which we have and OpenSIPS does not longer have, and we shut them off in CGRate. So this is what this channel synchronization interval is. I will also show this. And then you have the debit interval, which is set here to 10 seconds. So you can decide how often CGRates will debit your balance. And the rest are some modules which are too much to explain. You normally need quite some days in order to understand all, because there are quite some functionality, days like or months like Vasilios is telling here. So that's OpenSIPS configuration and CGRates. So now we'll try to see some communication between them. So for that I will set up an ngrep as you see it here, and before we do that, I have to show you something else. That was my, so when you start CGRates first time, you have no data inside, which means it will not know your accounts, it will not know nothing, it starts fresh. So it's same like you populate data in OpenSIPS, you have to also populate data in CGRates. And how do you do that? Is via two ways. One is APIs, but for this you will have to do quite some number of APIs. You need a web interface for that, or a better tool, or you can set up everything via CSV files, like you are used to in case of wholesale billing. You import normally price list over CSVs. So we will then USR share CGRates. For example, here you can see some files which I'm using for today quick demo. You don't need all, but this was meant for understanding more complex setups. So, for example, this is where you define your rates. So you will, this is how rate definition looks in CGRates. You can have the real rate, the connect fee, the rate increment, the group interval start. This group interval start allows you to charge every millisecond in a call differently if you want, or nanosecond. You can go up to nanoseconds. So you can add millions of rates if you want for the same call. A common scenario, I think Mexico is using first minute as a whole, and then every 10 seconds or whatever, or per second, or some other countries, they have some other exotic rating available. So you can go very verbose if you need to. So once you define also accounts, you define them here via some actions, which will create, for example, a monetary balance of 10 units, a top-up reset. So this is how you insert data, and then you will use CGR loader tool in order to get this data into the database of CGRates. And I use also config path. So it takes also the passwords from the database from my files, and then automatically inserts data. If I do verbose, it will also show me what it has inserted for me. So all these object, destination, rating plans, and so on. So this is how you inject and bring your data to CGRate side. So now we have data in CGRates. If you remember, we have also set up, by the way, the real binding. It's here. You can see that the carrier name, it's route 1 and route 2 when my account 1001 is dialing out. So, and this is priority based, but you can also have least cost or quality based and some other fancy scenarios you can think of. In my case, it's just some priorities so I can demo that to you. So the carrier ID, route 1 and route 2, are the carriers which I have inserted in my OpenSIPS database. So if I do a select all from DR carriers, you can see route 1 and route 2 as my carriers. So that's the only binding you can do. So it's a virtual binding. Of course, you can do many mistakes, but it gives you also flexibility. So this is what we have done, and now we will quickly look at data exchange. So for that, I'll make a call. Let's hope that everything runs smooth as always. So I can also capture the, I want to do it with ngrep because I'm using ngrep for both. So I'll just dial the call. I hope this means it's connected, yes. So it also should show me some messages here, and then I disconnect also. Again, it's showing me some messages, and we stay to see another synchronization so we can discuss about all these messages which you see here. This synchronization, if you remember, we have configured for every 30 seconds, so it will most probably occur within 30 seconds if we are lucky, or it sees that, no, I think it will not see anymore because the sessions are disconnected, and it sees that it doesn't need to do any synchronization because it has no active sessions anyway in CGRate, so it doesn't have to waste resources. Okay, so we still can see the sessions here. So the first thing what you see is from OpenSIPS side to CGRate side, there will be an authorized message. This comes from the place where we have done. Let me make this one nicer so you can view it more properly. I use online tool JSON-lint, so we can, I'm sure they are way better, but since I started a long time, I just started at some point with something and I was just using it. So this is the message which comes from OpenSIPS via RPC, and it's asking the process stats queue, which means involve the stats module in CGRate, process thresholds, which means involve the thresholds, which is the one which can detect fraud, release and allocate resources so we can monitor the channel use of OpenSIPS. The advantage of using channel monitoring in CGRate is that you can have a centralized place. So if you have multiple OpenSIPS servers, you can monitor them in one place in CGRate if you want the virtual channels. And you can also monitor only particular things, so only some, for example, just calls to Greece mobile if you want to monitor or limit the calls. Then we can also see that it's asking the routes, which means it wants routing back. Then attributes, this is the ones which are, this is this virtual database of CGRate, so you can retrieve data from CGRate. And then get max usage is call authorization, like process the maximum possible duration of the call. And then you see the event. Normally you have by default account setup time and destination and origin ID. And what is the rest? For example, you see here request type, origin host, and source. So there are 3 extra parameters, and you can see these extra parameters: request type, origin host, and what was it? And source. So these are the extra parameters which you were free to add in the script. So anything you want, you can combine with the billing. And the rest are default stuff. Again, we ignore the opt part. So these are the extra to the defaults. And the defaults are these things which are mandatory for CGRace to work. So there are some parameters which are mandatory and some parameters which are optional. Anything which you don't send out of mandatory, it will be considered optional. So it will accept anything which you send. So that's the request. And then let's look first at the reply and then everything what is going on after that. So you see quite some exchange of messages, because this exchange of messages depends on what you have selected in those opts. So now this is the result returned back. So in the result, I hope no, it's not that result, or it is. One moment. No. Hold on a second, because we can always look by the this identificator in order to see the answer. So yes, this is the answer on that request. So in the answer, we can see that this is the data which I told you it will be transformed into AVPs in your script, in that while loop which I showed you in the script. So you will have, you see, an AVP named password, which came from CGRate. So you can use this, for example, now if you want to authorize in your script the password. Some extra information which you might want to add to your request, the fact that it's a prepaid call, the LCR profile which was used, in this case is premium CLI, whatever, then which resource group was used, resource group 1, and route digest. This is your selection of the carriers. So this carrier was selected first, route 2, and then route 1. And also some thresholds which were processed by our request. All this information was retrieved, I showed, via this message exchanged. So chargers, I will not stay to explain you, but this is what's going on in CGRate's. You can also process it internally and you will not see that, but you can, this one gives you flexibility and you can understand the processing logic by just sniffing those messages. So it's not a black box, because many said it's like a black box, but by just putting and looking at these messages, you will see that it makes sense. The modules themselves, they are not very clever. So they only do some things. And if you learn the APIs, it will enlighten you very fast. So you need just to read this information. And after that, so after the authorization, then we received another API call, initiate session, which told us that the session was started in OpenSIPS. So from that moment, we start the debit loop. So we start this every 10 seconds debit loop, and we continuously take balance. You can also see the synchronization, because this time is coming from port 2014 and going to OpenSIPS over the same connection. So we are asking OpenSIPS whether what are its active sessions. And OpenSIPS will tell us our origin ID. So it will tell us what calls are active, and it will confirm us that this session is still active. So we have this security against unlimited calls. At the end of the call, we will get a session terminate session, so we know that we have to stop our real-time billing. You can see a refund here going on because we have taken too much. So we normally take every 10 seconds with debit balance, so we reserve it always in advance. And we realize that we have only spoken 6, so we give back. We put money back into the account. And then call some thresholds, and we also receive the CDR. So that's the thing which previously didn't work. So now we can see that OpenSIPS is sending us the CDR. So you can use CG rates as your CDR server for CDRs, even if you are not doing billing at all. So just as CDR storage, if you want to. And then we have some rates here, so it will tell us how we calculated why and how much money we have debited, and some processing of some stats and stuff like that. So we should also be informed via this CDR about the route which was taken, but my time is up, so I cannot abuse too much the next speaker's time. So I think that should be all. Luckily, it was working in the end. So I don't know, do I have time for a question or? Okay, any, please.
I'm really not familiar with the rate, but actually I have a few questions regarding the connectivity, security, and encryption. So actually, is it possible this communication to be encrypted over SSL or something between OpenSIPS and SIPS rate?
Yes, so we support TLS connectivity, but in this case, it is considered that it's a local connection, because you don't want your billing to sit somewhere outside of your server.
Some policies requires encryption even to local connection.
Yes, so we
Sensitive data, so actually you have to.
we support TLS for connectivity. I don't know if OpenSIPS supports, so that's a question for OpenSIPS.
Okay. The second question is regarding storage of the files. Do you support any kind of encryption, retention policies for GDPR?
So the good part is that we don't have to store it, so we can export it to your own machine. So we can put it in a RabbitMQ, for example, or send it over encrypted HTTP to your own HTTP server, and then you can store it in any kind of way you like or you need.
About passwords, I mean, you said about storing user passwords for speeding up the process of authentication.
Yes, we support hashing of those, but again, so this password, it's a dummy string. It's not a password. We don't know what's that. So you can already store it in CG rates as hash if you want to go that way and use it as hashed. I think in one of the talks yesterday it was the.
Okay, and I have two last questions regarding connectivity. The first is the timeout, you said that the system might be down, so there is a request and probably a timeout between the connectivity of OpenSIPS and the server. So
Yes.
is the timeout configured, and is there any caching on your end in order to provide data in as quick as possible, or should we do caching on OpenSIPS?
So we have caching on our side. Almost everything is cached other than accounts. Accounts not, because this is money and we always want to be stored. But the rest is it's all cached. Regarding timeout, you have to talk with OpenSIPS because they are handling the client. We are just the server in this case. So
This is a sessionless connection, or it's a static TCP connection that over there all the lines are communicating?
static TCP connection. So they can always reconnect. Nobody knows what they are sending. And if something has to be retransmitted, they will retransmit. We are done. We just answer questions. This is all we do. Thank you also. So I think we are all set. So thank you very much, guys, for your attention.
So, hello, can we start? Yes, can you hear me all? Perfect. Great. So, I'm Victoria from the Banafu team. Thank you all for being here and listening to my presentation and the demonstration that I will do. So, let's start. First of all, probably all of you already know what Banafu is, but I think it's worth mentioning one more time. So, the short version is that it's all about transcripts, you know. So this is the important part. This is the challenging and interesting part that we've been working on. But if I want to have some more specifics, it's related to conversations. Everything that you can store as an audio file, everything that you can upload, for example, or use the browser extension or use any soft form. So after that, you have the transcript, and you have possibilities to take notes, to highlight some important parts, to, for example, search across your transcripts, and to manage all of your conversations and transcripts there. So to demonstrate the transcription part, I will first go through the Banafu.com website, and I will show you where you can register and how you can easily test recording of an audio file and get your transcript. So you have the Try Now button here, but since I already have the account, I will just log in. So we have this one. So yeah, this is the main dashboard of Banafu, and this is the place where you as end users can log in and try the transcripts, of course. So on the right side here, we have the possibility to record directly, and this is recording my own voice at the moment from the microphone of the laptop. So after I stop the recording, it is already uploaded to the server. So now it's time to process it. So this will take some time. You can try it yourself after that also. Meanwhile, I will just show you where you can see the conversation itself. All of these conversations are here in this page, and you can listen to it. And here the transcript will show up after Banafu does his magic. And here is the place where you can leave notes, points of interest, stuff like that. Since I'm registered as a pro user, and this is currently free, so you can also register as a pro one, I can also download this file and have it here for the next part of the demonstration. So I would just take it and save it in the test files. So this is the recording that I just did. Apart from that, we have the browser extension. We have some integrations that currently, let's say they're not that interesting, but in the future we're going to improve and add a lot more. And now the interesting part is that, for example, if you don't want to use Banafo as an end user and to store the conversations and everything, you can use an API. Because if you have an application and you just want the transcripts part to get integrated in your application, you can use this API. There are a couple of ways to test the speech-to-text API we provide. One of the possibilities is to go in the configuration and to get your API key, which will allow you to authenticate and do the HTTP requests that are needed. This is an easy way to just test it, see how it's working, how easy it is to integrate, but have in mind that you have some limitations for transcript time per month, and if you do it from this account, it doesn't matter where the conversations are coming from, and it all takes from the same minutes per month that you have. But there is another possibility that, let's say, I will just go again to banafo.com. Here is some information about the API, some general things that you can read after if you want to. But there is another way to test our API. And this way is to go to this domain, banafo.ai, and register here. This place is a dedicated dashboard only for people that want to integrate the transcriptions in their application. If you don't want to see and to manage all of the conversations, to share them, to have the team part, notes, and everything else, if you just want to dedicate your time on the API, this is the place you go, and you register here. So I would just log in here again because I have the account prepared. So yeah, this is the place I was talking about. It's dedicated only to transcripts. So here you have only the needed part for the integration, like the API authentication. You have some kind of logs for your submitted files that you did through the API. And you have some basic configuration that currently have broken. Oh, wow. Okay. Yes. This is the configuration that, that we have. And the only things that we need from here are your default transcript language. By default, it is English, but you can set it to something else. Here there are some other things like to specify if you want your files to get deleted after you receive your transcript or not. By default, they're always deleted after that. So you don't store the audio after we give you the transcript. So let's go first to the documentation part, which is here. And here you can have all kinds of information, and you can go through the step-by-step guide in order to test the API. So now we did the first two. I showed you the dashboard, and I have the registration, so I was logged in. And here is something useful that we can now try in order to see this API, how it's working. We have prepared a Postman Collection that can help us demonstrate just the API. And for this to work, the only thing you need is, I think you need a Postman registration, but it's free, so you can go ahead and just do it. And here, in order to use the APIs, you need to authenticate, of course. And for this to happen, we need to add the API key. So this API key could be found in the authentication page, you click the Generate New API key, and here is the key that we received from Banafo. It's really important to copy this key right here and now, because after that you will not see it. You only see the prefix, so you can recognize it in your application. But you need to copy it, get it, and put it in the configuration of your app. So since I already copied it, I will add it in the globals in Postman. There is step-by-step guide here in the docs for after that. But the point of this is that I don't want to put it for every single request as a header, and I just put it as a variable here. And after that, it's set to the entire group. So I can make sure in this way that we're all set and we have the authentication ready and prepared. So now for the API. The API we try to do as simple as possible, especially now as a start. So we don't ask for too many required fields, because sometimes it's kind of annoying to have a lot of required fields, and we try to make it as easy as possible with some defaults. And if you want to customize something, you have the optional fields. So for a start, we should initialize a file upload, because we need the audio, and we need to know that in the next step you're going to upload something. In this step, you can provide to us some kind of metadata about the file, the file name and the language code. But these are all optional, so if you don't provide the language code, it will just get from your account the default one from the configuration. So this is a post request. The details about the fields are in the documentation, so I will just go ahead. And there it is. So I received the file ID, which is actually the placeholder that I'm going to need for next steps. This is an ID for the file that I will upload. And after that, when I look for my transcript, I need to pass this file ID everywhere. So it's really important to get it. And the other thing that we're receiving here is interesting, because this is the size that is currently uploaded. So we just did the request for the first time, so that's why it's 0, because we haven't tried to upload anything yet. But let's say if there is a slow network or something's not right and your file is not entirely uploaded, then it might be a partial upload. So on the next step, on the next time you try to get the info for this file, you can get that there's some number of bytes that are already uploaded. You can cut the file and continue from there. So we support this kind of resumable uploads. So we're going to get now this file ID and use it in the next request, which is the actual uploading of the file. So here I will add the file ID. And the other thing that I need is the audio itself, which is somewhere locally. So I will use, let's say, the file that I recorded earlier, which should be visible here. There it is. So I will use the same file that I used when we started this demonstration, just to make it simpler and to be an actual file that I just recorded. So I've added it here, and now I will send the request. And there you go. Now the file is uploaded. So now if I try to get my transcript, to get an info about it, which is some of the next APIs, I will see that it's processing. So before you upload the file, it's in pending mode, because we still need to upload it, and there is nothing we can process yet. So at this point, the file is in processing status, and it will change after we have some results. Here we have also the failure reason, which is something that can give you info if there was an issue with the processing part. For example, if the file audio is not okay, if it's empty file, or if it's just a noise and there is nothing we can get as a speech from there. This is the place where you're going to receive some info. So now, if we check, probably, yeah, it's still processing. Usually it takes 2-3 minutes to get the file done and to get your transcript. So what are the possibilities to get the transcript, meaning as a notification? This is one of the possibilities. You can set up a webhook. The webhook means that you give us a URL and we send a post request after everything is done. So there is no need to constantly check, do we have a transcript, do we have a transcript. The webhook will tell you, oh hey, the transcript is done, you can go and get it. Here, the other option is, like I just did, just to send the request over and over again and check what will happen. And in this way, I will just eventually get the transcript. But this polling is not, let's say, it's not recommended. It's better to use the webhooks and get notified by us. So here I have already the status done, no errors, and I have the transcript. In the transcript content, we have the text and we have timestamps for the started position and for the ended one, which is the important part, and it's all served as JSON. But if you want to receive the transcript as something else, because here, for example, is JSON, but it's inside, you have user ID, you have file ID, you have all kinds of additional data like the language and status, etc. If you want to just get the transcript and get the transcript as some other format, you can use another API. And this API gives you the possibility to specify a header and specify what you want to receive. If you just leave it empty, if you don't provide it, it will again give the transcript as JSON. But if you want to, for example, receive text, you need to provide the header, and then we'll give you the formatted version of the transcript, so you can just, for example, show it somewhere and skip the entire process of the JSON. And the other possibility is for subtitles, which is with this subrip header. And again, if you request it like this, you just receive the transcript formatted in a way you want it to. So this is the basic usage of the API, and this is without any extra fields needed. I just have it here as a metadata, but it's not needed. If you don't want to try it out using Postman and you want something a little bit, I don't know, easier, let's say, or real, you can also get a Node.js sample from the documentation, which I will run. So yeah, let's say replace. It's really simple demonstration code of the same request that we just did with Postman. Let's see. Is this? Yeah. Okay. So here I have one example file, and here I have initially the base URL and the API key, and the only thing you need to do is to add the API key that we already generated. I will just copy it from here. It's the same one we used for Postman. So we add this here, and that's it. We're good to go, and we can start it from the app. this thing will go, will initialize the file upload. After that, it will get the file ID, it will upload it, and it demonstrates how we pull, we do the pulling and just try to get the transcript. We check, is there a transcript yet or not? And after we have the transcript, we get it in the formats that we provide with the subtitles and the text. So let's quickly run this too. So the only thing that we need to do, of course, is install some dependencies, because we need the HTTP client to do the requests. So I will quickly do that. Okay, they're installed, and now I will run the script. So this is the placeholder I have, and this is the polling that I was talking about. When you upload the file, it's still pending. After that, our server gets it to process it, and now it's in processing mode. So this polling will continue making requests and asking for the transcript until we have something ready. So yeah, it will take some time. We'll see it in a while. Another way to do that, like we said earlier, is the webhooks. So to demonstrate that part, I'm using this. I don't know if you have used it, but it's really useful online tool for webhook demonstration. So there is no need to develop anything right now. We just get an example file, example URL that will wait for our requests, and we'll show it here. And you can specify the code or whatever that you want to receive. So I created a new one. It will expire after a while, but for our test scenario, it's completely fine. So while we're still processing, I will add it where it's needed, so we can run the script again, but with this webhook setup. So I think it was callback URL, the field that we need, and we add the URL that we want Banafo to send request to. Oh, and it's done. So here in this part, the polling is over, and we have the transcript status set to done, and we have, again, the result of the transcript as captions, and we have it as text. So now with the change that I did here, with the callback URL, I will run the script again, but I will disable the polling because we don't need it anymore. Now Banafo should tell us, meaning to send request to this callback URL and say, hey, your transcript is ready, you can go and get it. So now we don't have the polling. And here, the request will show up after we have the transcript done. Okay, it will take some time. So meanwhile, I will show you where you can also follow if something is uploaded, if something is okay or not. This is the Banafo AI dashboard. Here in the submitted files page, you can see it's really simple. It's just a list of your files, but it gives you enough information to know, for example, if the file is uploaded yet or it's not, what's the status, if there are failures, and the same things that we saw as results from the request. And after we have the transcript done, you can also download it because you want to check if everything is okay, of course, while development. And like we said, the audio files are automatically deleted. So here again, we have the three options for the transcript format, so we can download it in whatever version we want to. Okay. This is still processing. Yeah. Now we'll wait a bit. Let's see. Actually, we're going to to see it here. And there you go. This is the post request we received from Banafo to say that the status is done. We have the transcript ready. It's created. So this is the file ID, and we can go and make the request that I showed you earlier to get it in a certain format or in JSON directly. I think pretty much that covers the first version we have of the API. It's really simple at this stage. Here in the documentation, you have all kinds of information about the fields needed, about the upload, the transcript, the responses, everything needed. And some of the next parts that we plan to do and probably are interesting for you is the real-time speech to text, because currently it's only offline. You can only upload files on your machine and receive it after 2-3 minutes. But we also plan to add the real-time speech to text API, punctuation API, text-to-speech API, and things like that. Joachim can add more things if he has some idea. So, yeah, thank you for being here and paying attention to my presentation. That's in the audio length, no. There is a limitation in the size. It's 500 megabytes at the moment for the size. And you have a limitation for the transcript time, of course, yeah. Which in this dashboard, it's per month, but in the other one, it's in total. It's in credits, so you can buy more credits and use it for whatever time you need to. So, yeah.
What is the processing performance for like larger files? Let's say we have 1 hour of audio.
It's not that bad. It depends on the size. It really depends on the size, and yeah, but any more questions or no? Okay, thank you. Oh, we have time. It's a little bit early. Oi, sorry.
Cittadino sei tu più buono della situazione.
Diciamo che quando non ci pensa è una cosa che chiede. Come ti stavo dicendo, c'è una lista di naming, ti dico, quando devo fare un braccio non devo più prendere con un scaccio che ti dà 20 euro, e prendi il cartello, e prendi il scaccio, senza la doppia V. Siamo con la dimensione del unità barato, poi io da questa combinazione telefono, la nuvoletta, invece di hello, dietro, è vero pure perché è hello, no? Allora si può andare. Vedi, hai visto no? Però non era brutto. Tanto ci ha abbandonato un po', No, non dormivi poi non si ricorda. Non l'ho visto anche io. Good job. No worries. Thank you very much. Appreciate it. Will someone like cut them into pieces?
Either that or now you have just annotation, right? You just put the time and then you can just jump. Because with just a lot of work, we did it like for several years. Beautiful. Yeah, we will try it kind of flirt with the idea of maybe find somebody. But yeah, those time codes.
Got it.
Da, păi,
Da?
da.
O fac mai în față, că nu văd.
Păi nu o să fie. Okay. Hi everyone, sorry for keeping you 15 minutes past the hour, but we had the design clinics and the schedule was a bit crazy. Today I'm just going to try and build together with you some IMS components with diameter, and we're going to see if we can stitch everything up. It's going to be a bit of an experiment, I have to admit. I didn't prepare that much stuff ahead of time, so we'll see how it goes. Maybe I wanted to do a little bit of a recap on diameter. It's a follow-up of radius, which was way back 22 years ago, and they pretty much added some features on the transport, on the peering layer. So it's a bit of like hidden details in there. For us as programmers, they didn't change things much. We still work with AVPs in diameter. There is still kind of the same message structure, but the backbone has been improved. For example, they added security aspects into it. They defined the agent types. That's the terminology in diameter. Automatic negotiation, discovery, and all those kinds of things. And they started drafting all sorts of, rather writing specs for all kinds of requests from router configuration protocols, also for voice and all kinds of networking interactions have some equivalent with diameter. For example, here the basic requests you're going to see when you start working with it are connection establishment request, the CR, and then you'll get the periodic pings, the device watchdog requests. And the last one is like the termination request. The packets, pretty much, it sounds complicated apparently, but actually it's just a bunch of AVPs. It's nothing much more past AVPs, just some flags, a command code telling you the type of request it is, and the app ID, which is kind of a holder for, under one app ID you will have a series of commands. And the AVPs can be integers, strings, or they can be kind of recursive, like an AVP holding multiple AVPs, and that kind of structure, kind of giving. Today we will be doing some grouped AVPs as well as part of the 3GPP application. We're going to be doing pretty much trying to do an HSS. And we will do the user registration, the storing. I'll get to that in a bit. So that's about it with diameter. Some slides. These are probably, if sound familiar, these are slides from some other talk I had on it. And a little bit of a rundown through the implementation we chose in OpenSIPS. To provide the diameter, we actually went with free diameter project, which seems like a proper choice, especially since they market it that way. They although it kind of started as a kind of a research project, they actually had some real-life use case for it, and they wanted for it to be production ready. So it seems like a solid choice. And it is, you only need to know about it is that it takes care of 2 layers for you. It takes care of all that interconnection between the endpoints part, which is the peer state machine layer that is on the bottommost side there. So that includes the pings I was talking about, right? The watchdog requests, the connect, the capability negotiation, because that is, I will get to that, and also you will see during the demo that if one agent doesn't have the capability to handle a request, it will simply give you an error when you try to send that request to it. So those things need to sync up, right? So the sending agent needs to have the same capabilities as the receiving one. And obviously there's the parser. So once we negotiated and we had this session, the peering, we can start sending messages which need to be parsed. And once they are parsed, we write our upper logic. And that is finally where we work at in the OpenSIPS script, right? We write an app and bake some logic into all of this. Those two are provided by 2 nicely available packages, but only recently. So if you're still sticking to some old OS like Ubuntu 18 or Debian 8 or 9, you won't have those available. So it's nice that to see things moving on, even with the free diameter project. I'm not sure if it's the merit of the maintainers or the free diameter, but it's probably a bit of both. The OS maintainers, yeah. So those are some shortcuts for installing it. No need to compile it by source. And on the OpenSIPS module side, we have this AAA diameter module working with these 2 libraries. And at the same time, on the receiving end, we have to have a client on, because OpenSIPS acts as a diameter client, but we need to write an app on the server side as well. So free diameter allows you to write these nice applications, but they actually have a naming convention for them. They are all following the same interface, but the convention is RTs for some real-time. Honestly, I haven't worked with them. Some debugging. The dict ones are simply providing structure, right? So you get what we are going to do today. Actually, the 3GPP application is not part of any of these dicts. So unfortunately, it's not part of the, here, the 3GPP dictionary. So we are pretty much extending it with some HSS functionality. And on the OpenSIPS side, we wrote app OpenSIPS. So it's not yet, I've not yet made the pull request to them. Maybe it would be nice to have it in the future. Right now, since it's still like alpha, it's still in the OpenSIPS project. You will find it in the, I hope I have a slide for this, in the OpenSIPS modules, AAA diameter app OpenSIPS. Well, this is the configuration on the client side. You define, if you notice on the bottommost side, we have the connect peer and the free diameter. It's kind of a two-way interaction. You can, when you restart OpenSIPS, the OpenSIPS free diameter client initiates the connection, but at the same time you can restart the other one. You can, if you restart the free diameter server, then it will restart its peering connection to the client. And don't forget to load your extensions. Here we will be loading both the built-in dict SIP, FDX stands for free diameter extension, and also our app that we are building, the app OpenSIPS FDX file. And of course, the since diameter is stands on security, that's why they wrote it. They kind of require you to take care of the TLS side as well. You will not be able to start it without TLS certificates. Okay. Yes, and these are some built-in applications on free diameter that we have in OpenSIPS. Your authentication and accounting applications that we're working with Radius are also working with Diameter, but they are highly custom, I would say. So, for example, although we use MAR, Message Multimedia Authentication Request, we baked in some custom AVPs in there, or some customization, which I'm not sure if it makes it compatible with any kind of MAR supporting server other than the app OpenSIPS. So, as I told you on Tuesday, this was more of a research. All of the Diameter is still on research phase. There is no kind of a real life project we are following to get all of this functionality going. We are just trying to get the ball rolling, maybe get some feedback. We push out some stuff. Maybe people try it and build some projects, get feedback from them, build some more on top of it. That is kind of the intention here with Diameter. Right, and here are the authentication packets. Maybe let's talk about some AVPs, because there is plenty of time. That's what we'll be doing for the remainder of the talk anyway. So here we have since we're doing authentication, there will have to be some authentication credentials, right? Your usernames, your realms, your nonce. And of course, this is the answer. It's somewhere in there is a success message. 2006. Okay. Diameter success, server name not stored. And the other application, the accounting, which is code 271. Again, it's dynamic, by the way, so you can inject as many CDR fields as you want into it. They will get automatically populated as you define your $ACC extra AVPs. Okay, and that's about it for the presentation. And now I will be fighting with the script in trying to decipher all of this, because I'm going to start with this profile update request. If we look on the left side, I'm just following the specs for the SH application. And the HSS has at least two sides we are going to follow today. We have the right side of things, right, where we get the registers and we are making these Diameter request equivalents to store the data in the HSS. The way, at least I'm not sure, please correct me if I'm wrong, but the way I think about IMS is that we already have it. Like OpenSIPS is doing whatever platforms we or you deploy. They have everything that an IMS platform has. It's just that they are not neatly organized into proxy CSCF, ICSCF, serving CSCF, and HSS, and all of that. But think about the location, right? The user lock module. It's just save and lookup, and the location table in MySQL. That's your HSS. So it's just a matter of repackaging everything into an IMS kind of architecture. So this profile update request, if we follow the docs, the good thing is that not AVPs are mandatory, right? If we look at this DRMP AVP, by the way, I apologize if I don't know much about these AVPs. Maybe you've worked with them and you know what it means. I have no idea what it means. And they say that we can get away with 0 occurrences, right? So we should be able to just skip it. Like all we're trying to do is just to make an equivalent of user location today. Let me close out some of the terminals I have, and here is a script and profile. We will simply call, there are also all kinds of hacks in this script, like this is my developer script. So on the register, pretty much we will be following this. Oh, it's too small of a font. Okay, let's bump it up. Maybe one. Okay, it's still workable even from here. So we're just going to do this diameter and okay, let's also save it in our own location. Let's not skip that part. As long as we get the message processed on the diameter side, we should be good. These are from a previous message. I've copy-pasted, and we are going to start building these new AVPs, which, by the way, they will not get recognized, I just realized, because there is this configuration file that we need to educate the library with before it can send the requests for us. It's actually, it's both, yeah, exactly, the dictionary. It's both good and bad that they are so nitpicky. This, I don't remember his name, the French guy who wrote it. Because, for example, if we try to send, there is, since OpenSIPS 3.3, you get this nice diameter send request function. There's, maybe, let me put it in the middle. This diameter send request function, and you give it the app ID, right, the kind of a holder for all the applications, for all of the requests into it. And in our case, it is something with 16 million. Not sure if I can spot it. Oh, there we go. Application 3GPP SH. So it's 16,777,217. Very easy to remember. And the first command, the save, pretty much, right? When we get the register, is it's a 307. Okay. And that is the body. It should be. It's an easy one, right? At first, you just store it, and the diameter, for all intents and purposes, is easy. It's just request reply. There is no, right, multi-message transaction. There is no state. There is no dialogue or transaction state. It's just, you can think of it as HTTP to a certain point. Okay, so let's also define this structure in the ACC-conf file. That's what, I still have it open. And to define the larger structure, like the message, that one depends on AVPs. So the first step is actually to go through each AVP and define it. So session ID, that should be a standard AVP. Vendor specific, pretty sure we have it. If not, it will yell at us. Auth session state. Let's just be sure. Should go with integer. There's something wrong with this back button. Anyway. Origin host, origin realm, we have these. Destination host, it's standard. Oh, and it's optional too. Realm as well. Supported features is optional. User identity, this does not sound familiar. 700, and it's grouped. And the problem with grouped is that we are going to have to see what it's made up of, so we can define that structure as well. So it's called user identity. And it's 700. And we have the grouped type. And now we have to, oh, it says here. So we got, but it has 0 occurrences of each of, right? It's made up of 2 sub-AVPs, the public identity and the MSISDN. But they can both be missing. But the user identity is mandatory, which is really confusing. Like, how? Why do I have to put an AVP that can hold nothing? Like, anyway. Yeah, maybe I'm missing something, right? Contained AVPs, I can get away with an empty user identity, right? Unless I'm missing something.
Probably they don't support like.
An empty. Yeah, you have to pick one. Oh yeah, you're right. So it's at most one. Okay, so let's go with MSISDN because it sounds cool and I have an idea for what it means. Yeah, we know what it is.
We know the last four letters.
It's a number, right? Telephony number. It's an octet string. Okay, so let's define it. MSISDN. It's probably the number for which the registration is done. Although a SIP register won't include your number. Is it in the from? Maybe. Yeah. The 2 is the OR. It could be the 2. You're right. Octet string. Okay. And it's 701. 701 string. This is not group. Yeah. Okay. We're done here. So we have the user identity. Okay. Wildcard, we don't need. Data reference and user data SH. We got 2 more. Data reference is 703. I should have done this. So this is on me. I apologize for not having done my homework. Enumerated, so that's just an integer, not a big deal. And that's it, I guess. We'll keep this in mind. But since it's funny, since we build both the, so for the sake of this application, since we build both the client and the server, I mean, we have complete freedom, right? Things will probably be a bit more rigid, or we would have to be thorough if the server were some kind of like a carrier infrastructure or something like that, that will just reject your request otherwise. User data SH. It's 702. And it's a string. Thank God. Okay, so we did both of them. So now that we have the required AVPs defined, we can go ahead and define the whole request. The profile update request 307. I actually extended the syntax of this file, and previously with radius it was a simple structure, but now with attribute I just thought it would make things easier to keep it that way. Maybe I should have done a different name, because you can both define an AVP and a message. Or maybe no, I was wrong. Never mind. I confused it with the grouped AVPs. So it's a request. It sounded fishy. Why is a request with attribute? 307. Maybe I should do it like this. Not really. The session ID will be in there as a default in diameter. The library will put it for us. Let's go with the vendor specific. Hopefully it's in there. It should be in dict SIP. Okay, required 1. Origin realm. Okay. Yeah. Okay. And the auth session state. It's required with, by the way, we have required, optional as the second parameter, and on the last one is the maximum number of occurrences. So we put 1 for each, right? Like we don't want to allow duplicates. Origin host, it seems we need that one as well. Destination realm. Okay, user identity, the fun MSISDN one. Okay, and just data reference and user data SH, and we are done. We can get away with deleting all of the other ones, maybe like that. Okay, so now we define the reply as well. Hopefully we don't have to define. So on the left we now switch to the answer packet. Profile update. So the code stays the same. It's still 307. And these strings that we see, the profile update answers, by the way, just for making sure you got this, they don't actually reflect in the diameter packets, right? They are they're just binary data, and they just hold that integer. For a computer, it's enough to see 307, and it knows the request. This is just for human readability that we name each of them. So let's just copy what we had in the request, and we will just maybe make some tweaks to it. Session, we have this one, result code. It needs a result code, of course. So I put it in there. It's also optional, apparently. So let's make it that way. Auth session state. Oh, this is nice. We can remove all of them. Probably, logically speaking, right? You only need to know if the storage was successful or not. If it made it into the HSS, and that's why you can keep all this stuff optional. And I think we should be good here. Maybe define the application as well. Yeah, this is a problem as well with the library. So we have to explicitly tell it to remember this 16,777 number, and we can call it 3GPP SH. Application, why not? Okay. And that should be enough for us to be able to do the same thing at request level. At the script level. Is it still here? Okay. How do I do this? Let's do it like this. And maybe just copy paste from that one. Just put them here, and we start building our JSON. Vendor ID. At some point, we should start reading up on what these AVPs mean. I'm telling you, like, what integer? It's an integer, right? Oh no, it was the one we thought the library knows about, but still, it's grouped. Awesome. So we need structure. It needs to be an object. So this is how we represent grouped AVPs, right? It's a key pointing to an object, and now we have subkeys. And which one? Let's go with a vendor ID. So because the other ones we can omit. So this has a sub AVP. Finally, an integer. Okay, why did they have to do this? Vendor ID. Now we just put 0, right? Okay. So one is done. Origin realm, easy. We've done that. Destination realm is the same. It's the testing. And there's something wrong with the highlighting. Oh, it's due to this. Never mind. The auth session state. Not really. Okay. Let's read the manual. It's an enum, which can take values from what? It's just 0 or 1, right? It's like, but it's a nice way of saying 0, right? 0x, 8 zeros. That's 0 for sure. Maintained or unmaintained, or no state maintained, yeah. Okay, we don't maintain any state. It's 0. Origin host. And realm. Oh, we already have those, didn't we? I think I duplicated one at some point. Okay. No, we want the host, not the, okay, that way. And now the user identity, and I think this one was the grouped one, right, with the MSISDN. Let's go back, just double check. Just to make sure we don't make any errors. How could we make an error, right? Identity. I'm looking at the answer, unfortunately. There we go. By the way, if you have any questions or any complaints about this tedious process, feel free.
Do you have to define the group in the left as well? The user identity?
I think we did, right? Or am I? It's here. Look, it's grouped.
Yeah, but like define the structure.
I'm pretty sure we did it at some point. Hope I didn't forget. Oh, we did not. Yeah, we do. Thanks, Vlad. We just defined the sub AVP, right? The MSISDN, but we forgot about the group structure. So now, see, Vlad should get a cookie.
I just woke up.
You on coffee? Oh. The user identity. 700 grouped. And I told you we are building both the client and the server. It will work. Like the problem is when you try to interconnect with some other device. That's where the problems come in. So it's MSISDN required. Let's just set it to required. Let's forget about the other one. Nobody will punish us. Okay. And what kind of number does this take? Let's see. It should be a string. Okay, it is a string. Okay, let's do some fun number. Some Romanian number. Okay. I think it's... So that's out of the way. Now we got two more left, data reference and user data. It's enum from 0 to 33 indicates the type of the requested user data in the UDR and SNR operation. Yeah. This. Okay, let's go with 17. Yeah, just for example purposes. User data sh. User up. And the other one is a string that represents the user data in UDR, SNR, and PNR operations, and the data to be modified. Okay, so it's this actually starts to make sense. So it's probably the AOR, I think, the data to be modified, right? We are storing a contact on an AOR. This is how we talk in SIP, not in, not in diameter. The only one with some good document, yeah. This is a nice reference, this mobilium.com website. Whoever took the patience to write it, they deserve like good stuff. Also these nice links and everything. That's probably automated. Okay, so let's go with Giovanni. Yeah, okay. I don't know, it looks okay so far. Looks like a proper PUR profile. What does it stand for? Who remembers what PUR was? Profile user request? Profile? I forgot. Profile update. We are updating, like save. Yeah, we are saving. Yeah, save, update, write. Okay. Yeah, profile update. So this is the building block to HSS. The first thing an HSS must have. Okay, so we have this. We could theoretically run it right now, and it should work, but the diameter server should complain with an error, or should it? That it has no handler. Right. Although it will be able to parse this request, since there is no callback to consume it, it will stay unconsumed, and it will rise up to the like an exception, right? And it will bubble flow to the top, and it will end up with an unprocessed message, and that should be an error. So let's start the OpenSIPS. Failed for some reason. Failed to load the file, so we might have some kind of a syntax error in the file. Oh, there we go. From the first try? Oh, I see. But it's just a typo, probably, or yeah. Anyway, it didn't work.
I'm 50-50 on the beer. It's just.
I have no idea why it doesn't like it. It looks proper. This maybe says something about my parser. Failed to parse line. Maybe we can look at where it got stuck. So it did ppcost auth session state, and then it started erroring. Also it's something with here, with the user identity. It could be a duplicate. Exactly. So it is quite nitpicky, and the library doesn't like you to redefine an AVP. Whenever you do that, it's like, okay, go away. So do I have comments? I hope I made comments. Let's see. Yeah, did we? I think it worked. I think, look, we made progress because last time it.
Conflicting entry.
Yeah. So now I think it parsed like maybe the whole file. Where did it stuck?
It's resume code.
Command code. So we defined the command, the answer, and the request is here. So we both the blocks worked, right? Profile update. Okay. And finally, it doesn't like error occurred. Conflicting entry result code. Did we try?
Maybe because it's about
Result code. We can try to remove it. Maybe it's from maybe the library automatically puts a result code in an answer because there is no concept of an answer without a result code. Right, so by us okay, we started, okay. So the file is correct, and we taught free diameter a new request and reply type, the profile update request. I'm keep saying it to remember it. Okay, so let's follow the logs, I guess. And I have here some CP with a simple register, and we should see no errors on that. That went by fast. Okay, error. Failed to okay, so maybe I made a JSON typo. Failed to parse JSON. Obviously, no pointer to where, but we'll find the error. Let's go with. I did insist on this way of defining it with double quotes at the start. You could do it like this with a single quote, and I'm pretty sure it's multi-line string, and it should work. And we could avoid all these back quotes. The last one, I see it now. I see it. I'm used to the C language tolerating this for me, but the OpenSIPS JSON doesn't. Yeah. Okay. Yeah. Okay. Did we have success now? Error. Bad AVP. Only string allowed. So we did something with the vendor app ID. Show 7.
Maybe it's not there because it seems to be 0. Maybe it's just not there.
Let's see.
No, vendor ID
Only string allowed.
explicitly 0.
Maybe it's a yeah, but I remember it's an enumerated. Yeah. Let's try string, and we'll go from there. That is weird. Let's.
Same thing, but in vendor specific.
Oh, you're right. You're right. You're right. Yeah, it's vendor. Maybe we have some little error or vendor ID. Okay, let's do string and yeah. Not sure why I did this. I think I forgot a bracket. What am I doing? Backslash. Oh my God. Okay. Searching. So now we made progress. We are at user identity group AVP. And again, we get the same thing. This is starting to look like some internal bug, or I don't remember how to give it grouped AVPs. Let's check the docs, maybe. So we have this. Okay, it was my bad. So for example, we have this example with the cost information. Of course, it's a list of JSONs, right? It's not a, yeah. So let's take it as a reference, and maybe this one was actually grouped. I will double check that as well, just to make sure we don't screw it. It is grouped. Yeah, it was. So we did the right thing before. So let me grab this on into memory. Okay, and now we go back to where it was. I think this is the way with an integer. Okay, we go back and we replace it, and we should be good. And we fix the other. We need to fix it. So it's a list of JSONs. Okay. And the sub AVP is just key value. That should be easy and correct. And we do the same for user identity. Just put the list in there first. Okay. Give it another spin. Error. okay, this is starting to look good now. So we, all the AVPs from our JSON were put into the message, and we get this nice message from the bottommost layer, the peering layer, which says successfully sent. Okay, so it sent it. But unfortunately, due to the capabilities, you remember I was talking about earlier, there is no server-side peer to have where to send it to. So it's like, okay, I'll send it, but I have no peer. There is nobody to send it to. So it bubble floats back to the top, and you get this routing error, like no candidate. So it worked in a way. So now we go to the server side, and let's do some C coding in app OpenSIPS. Ooh. So we can close this, and the good news is that both app OpenSIPS and the OpenSIPS module both read from the same AVP's conf file, so you don't have to, we don't have to work on that one anymore. So we go to the root of the free diameter. So right now, wait, sure.
Just for my understanding,
Yeah.
if the SH specification was into an extension of free diameter,
Yes, yes.
there is no need for the configuration file.
Exactly. I have the slides. Let me show you. Exactly. No, you just do, where was it? The structure, this. You just do load the extension dict Giovanni 3GPP .fdx, and the whole thing is loaded into both the OpenSIPS client and the server-side free diameter daemon. Yeah, and then you just use the AVP. You can send the request, the profile update request, without errors. Yeah.
An extension, and then so you can
Yeah.
link,
Nice.
and that's it.
And the Apple, I actually made a symlink here, but I will show you what the structure looks like. So they have this, so from the root directory they have these extensions, and I don't think there is a subdirectory anymore. We already have app OpenSIPS in there, and if we list it, it should be a symlink, which just, we can just go to OpenSIPS and we code directly in there. Modules, AAA diameter, app OpenSIPS. We already went past the time at this point, but I'll maybe just go through what we have to do here. Because at the end of the day, we will just receive a message and we just decide what to do. We can store it in memory or some sort. I guess it's not that valuable to store something without also being able to fetch it. So we wouldn't, for the demo to be really cool, yeah, we should be able to make the other, what is it? The profile, no, this one, the UDR, the user data request. So when I call CP, we actually find something in the diameter server. So that would be cool. Right, so here, let me tell you where is the initialization? We have some callbacks here. We register these disp register functions. And here, for example, is where we register the author request and the accounting request. And there should be one more for some custom requests, which are probably data app, data. Okay, so pretty much we would do the same thing. Let's follow a similar pattern to how we did with the accounting request, right? So let's grab that code block. And let me make some space. And here, for example, we have this search. Actually, it says search, but it will also create the application if it's not there. Application by name, and we would use the 3GPP name, and also register the accounting request and hook a callback to it. So pretty much that is how it would work. So it's similar to have here, it's how we have here the accounting request, and maybe just follow along here because things wouldn't be that much different. So we drop everything that's not a request if I'm not. Yeah, here, just to make sure it's a request, right? We have an if block, and now we go into each AVP it has. We can here, for example, there has to be some loop at some point. There it is, this while loop that goes through all the fields in the CDR. So it can write them to the file and store your CDR data via diameter. And in our case, with the profile update request, we would maybe use a database, maybe follow a similar architecture to how OpenSIPS is doing it, right? With both caching and database, and maybe do a mix of those. And that's how we would build the HSS. Yeah. I guess that was it, because we are already out of time. We did start late, though. If you have any questions, I know it, sure. Vlad.
How do you get the reply? I mean, you're showing us how to search.
Good questions.
But I want to know,
Yep.
was it successful? How was happening?
Let me show you. So Vlad's question? Huh? Vlad's question was, how do we get the reply at OpenSIPS script level, right? We send a request, but how do we know what was that? Result code, AVP? How do we get that? And there is this nice third parameter. Sorry, not, is this an old script? I think it's an old, yeah, it's an old version. Let me go to a modules page. I'll show you from the docs. Yeah. Okay, so there is a fourth parameter we added at some point. Let me zoom in a bit. It's reply AVPs, pseudo variable, and I think it has to be. Oh, it's still a JSON, exactly. It doesn't have to be an AVP. So it's a JSON, you parse it, and you get all the AVPs. Initially, I just extracted the result code and gave it back, but we thought that it would be that useful, right? It's better to just give all the data from the reply, and you can walk through it, you can parse it, you can do everything you want with it. Yep. Sure, Johan. So can you parse the JSON? No, sorry. Can we parse the JSON reply, is the question. Of course, it's just like the request. You parse, okay, I can show you how to parse it. Let's say if we imagine we have this fourth parameter, the var RPL reply. You would do $JSON, right? RPL, you can use the same name, equals var RPL. And that's it. Now you can access subfields in the JSON. You can there is iteration. Yep. JSON RPL. Let's say / result code. Right. This is how you would read the integer. I can scroll up a bit for you. That is how you would access stuff from the reply. Sure. Okay. Thank you.
Stop imagining you with an apple in your mouth and go eat.
What?
Check, check, check. Yes. Can you hear me better now? Label. Am I going to get the last name right now?
It's not written.
Okay, Vlad Patra.
But I don't not do that.
It's back on. Talk now.
Can you hear me? Yeah? Okay. Okay, so continuing from my presentation yesterday, we will be looking at a simple implementation, so how to configure in OpenSIPS SIP message to MSRP gateway. Maybe just a short recap. We are trying to pass SIP messages from SIP message only client to an MSRP one. Okay, and yeah, basically we want to start the session either from the SIP message side and then to start an MSRP call on the MSRP side, and also from the other way around when we start with an MSRP call and then we want to send SIP messages on the other side and receive SIP messages in this session. Okay, I'm gonna go away from the presentation now. Okay, so in terms of clients, we'll use a Blink. It was the only one that for the moment we got to working with MSRP, and for a SIP message or SIP message only client, we'll be using a client command line tool from the SIP Simple SDK library. So just to have a simple client that sends SIP messages. Okay, and as a setup, we have a simple OpenSIPS proxy just to help with the routing and registering the Blink to it. An MSRP relay, and an MSRP relay OpenSIPS instance, and the gateway instance, itself. As a starting point, let's just look a bit at the MSRP relay. So we have an MSRP socket on 2855. So it just works kind of out of the box. Only we need to define the URI, the MSRP path that the relay will provide to the clients that authenticate, and a very simple authentication route here just to authenticate my Blink with the same password. Okay, so now on the let's look at the gateway itself. Here we'll add the scripting functions that we need, but I've just added beforehand the gateway MSRP gateway module parameters and other parameters. So we have here an MSRP listeners 2856. We have a SIP listener for receiving the SIP messages. So for the gateway module, we first need to load an MSRP UA module. So the MSRP client endpoint implementation in OpenSIPS, because we will originate SIP MSRP calls from the gateway. This module is based on back-to-back entities, so we also have to load back-to-back entities module for the
client dialogues, and proto MSRP, and that's kind of it. So first thing we need to do is translate from from messages to a new MSRP session, SIP call. We do this with the message to MSRP function. Let's take a look at. Okay, so we need to use simply this function.
Excuse me, we had some problem with the microphone batteries, or no?
It's good now.
Now it's good.
Yeah.
Maybe. Someone change the batteries?
Yes, wait.
Just thinking. Okay, so the idea here is when we receive a SIP message in the script, we simply need to call this function to process this SIP message and send the 200 OK reply to the message client, message only client. Okay, and exit. So now the first time that we receive a SIP message, it internally creates a gatewaying session and starts a call with the MSRP side. And every time another SIP message is received, this session is looked up and we simply send the payload in MSRP. But the idea here is that we want to correlate. Let's see. We want to correlate messages that come from the message side with messages that may come from the MSRP side. So we need to use a correlation key. So something that links the message client that doesn't have a session. So it's every time it looks like it's a new session, but we need to correlate it with the gateway session that we have and with the MSRP session. So for this reason, for example, the most simple key that we can build is something based on from user URI and to user URI. And we'll do something like this. So it's a composite key from user and to user. Let me check. Okay, this is the one. Okay, and this function also needs the content type to advertise in the SDP offer in MSRP. So we'll simply use text plain, but since we're going to be testing with Blink always sends HTML, or encapsulates the message in a simple HTML body. Okay, so that's it for the message to MSRP side. So let's start this and see if we can make a messaging session between those. Okay. Okay. Sorry. Okay, so now the gateway has started, and let's check if the blink is registered. It's registered. And here we simply send a SIP message from this account, MSG client 1, to the Blink VM1 client. Let's see. And now Blink accepts an incoming session, and we see the message. So when in SIP, okay, in SIP we see an invite with an MSRP offer. The call is established, and here is the message. Okay, the microphone fell off. Okay. Okay. And here we should see the MSRP that we sent. Okay. So this is the actual MSRP message with the payload. And now if we keep send messages, they are part of the same MSRP session. And if you want to reply from this side to the message client, we'll just start this as a listener. Okay. Test from Blink. And we see on this side, test from Blink received as a separate SIP message. Okay, this one. So it's going from the OpenSIPS gateway to the SIP client. That was the MSG client 1. Okay, so now let's try to do the other side. So if we initiate a session from Blink and send a message, to this client. So here we have an invite from Blink. And now we need to answer that initial invite from the OpenSIPS gateway, so the user agent endpoint in the gateway. Let's try something like this. So here we have to put the correlation key, but in the reversed order. Because when we answer it from, let me. Okay, so when we answer it from this side, now when SIP messages come from this side, we need to correlate it with the session that we created here. And here we have the from URI from the MSRP client, from the Blink. And as parameters, just the content types, so the SDP negotiation works. And the last parameters for, where was I? Okay, for MSRP gateway answer are the from, to, and request URI to use in the SIP message request. So basically what to put here.
Did you have to reverse them? And the from and the to?
Yeah, I meant to reverse them. Okay. So we restarted the gateway. Okay, now we listen for messages and call this test client. What's the MSG client one? We start an MSRP call with it. Okay, so this is some initial handshake that Blink tries to do, but we can see an actual message. So here, wrapped in this HTML, is the message from Blink. And now we can send different messages. Okay, we have on the Blink side, sorry, it's a single call, a single session, and we see these separate SIP messages. No, not this one. Where is the? Sorry?
Can you fork the invite? Can you send the invite like parallelly from a few destinations?
At the point in the gateway implementation, no. It's just a single invite. And maybe in the same session from Blink, we can try to send from the client a message. Okay, so see message from client. We don't know how long the SIP message user wants to keep this session active. So for this purpose, we simply we define some timeouts. So if no SIP message has been received from the message side after, this one, after a number of seconds, we just kill the session, send a buy on the MSRP side. So this is one way of ending it. So here is the idea. So we don't know when to send this buy because we don't have a session on this side, and we wait for a number of seconds. Oh, I have it here. Let's put something like 15 seconds here to see. No. Let me restart it. Okay. So start the call from here. And we should wait 15 seconds, and the MSRP gateway should kill this session on this side. Let's hope it works.
Count 15 seconds from the last interaction or from the login? When it starts?
15 seconds from the last SIP message received. We have a different, if you need a different timeout, that it's the entire session. So either a SIP message or an MSRP sent from the MSRP side. Okay, so it's...
So it's either side?
Sorry?
It's either side? If either side doesn't send a message, it kills it?
Yeah, this one, session timeout, but the message timeout is only from the message side.
Oh, okay.
Okay, so here the buy has been sent from this side. So this is the OpenSIPS gateway. Yeah.
At this time of implementation, what happens for the messages that are sent to the
Sorry?
client? What happens to the message that was sent from the offline client? There are some type of store of the message.
No.
Usually the
No. The only queuing of messages that we do is let me. So here, if we receive the initial SIP message, call this function to start the call here. Up until the call is answered, each SIP message that we receive here will be queued and sent as an MSRP send later when the ACK is received. So this is the only queuing that we do.
It's like dialogue will be, is it the dialogue oriented? Like, can we see later, do we have the ability to correlate those open like those open conversations?
No, it's actually it's the MSRP UA that does all of this. So it uses back-to-back as a not a proxy dialog but a client dialog from OpenSIPS to MSRP client. Yes.
So this MSRP gateway, it will work in, let's say, snapshot type of environment. There is no history of messages. There is no collection of the messages. So if you
No.
lost your client, then you open it on a different device with your number. You can't go back to your history. You don't have any recollection.
No, at this point no. But maybe you can cache the messages here and send them later. I don't know. But it would not be done automatically. But we can maybe use the MSRP UA module that has an MI function to send a message. So this message takes a session ID, an MSRP session ID. And on the gateway side, we can list the active gatewaying sessions. And in this, the output of this command, we can see the session ID of the MSRP session. So we can later maybe send them with an MI if we cache them here.
I'm saying that
So that's-
successfully send it, and the session ended, and I close my client or reinstall my client, I can't go back to my messages. They were never stored anywhere.
No, they're not stored, no.
And there is no, do you see any way how you can implement that?
Yeah. Yeah, and then we,
Populated by MI. Like the idea that we did something like that by just pulling it. When you are going scrolling up and you want to get more history, they are asking the backend to send it to you. Those
But you
messages.
need at least have the session IDs to
Yeah,
request that.
but you need again, while you're sending the message, just put them in some database.
Yeah.
yeah,
You
so,
don't want OpenSIPS to become your data store.
okay.
What should be the best parameter to correlate the message to? You have like session ID in the message header or
So to correlate the information on the SIP side that we have here with the,
No, what the MSRP side, what is the net fetching, but it's a call ID, right?
it's something that works like a call ID. Yeah. It's so in the when a MSRP endpoint sends a message in its from path, it puts a session key here. So practically this is something like a call ID. This is a message ID. But we don't need to do this ourselves to correlate send messages between themselves. Or
each one of them has a different from path?
no.
Two
It-
sides, both sides contain the same from path values? Messages, I mean?
So you mean the from in the MSRP to the to URI, and on the other side it's the same but it's reversed. Maybe we can include other information like I don't know, user agents if we have multiple calls between.
What about the session ID, like that correlates the messages to the same session?
Yeah, but on the message side, we don't have a MSRP session ID. Maybe we can add it as an extra header in the message. Yeah.
Do you have the ability?
But it's configurable. That's why I wanted to stick, because you simply put a key here that you build yourself. So you can imagine ways of correlating a SIP call with a separate message, SIP messages.
What is the abilities to control like the ringing stage, like from the invite until you are getting the 200? Can you cancel it? Can you redirect someone, for example? Can you make, if I'm starting a conversation with you and you didn't react, can then we somehow manipulate this conversation to go to a different one or something like that? Do you have any mechanism to implement such a stuff?
So something like forking, you mean? So okay.
Of course, fork is the ideal,
Yeah.
but even not like just fork, just
No, at the moment the SIP client in the endpoint in the MSRP gateway module is a simple one. So it's based on the MSRP UA module. So it's we don't have that ability at this time. But
Where do you configure the timers for the session?
here in the gateway module. So it's a session cleanup is different. It's a session timeout and a message timeout. Those are basically the most important ones. This is just for cleaning up sessions that maybe.
Any way to at least detect, like if the MSRP stuff didn't work, there's no like feedback at all.
Oh yeah. I wanted to touch on that too. Yeah. So if we receive the message, SIP message, and start on MSRP session, and the session failed, maybe we want a way to notify the message-based client. So we have an event from the gateway module, and we can catch this event and send a message separately to the message site. I think I have something like this. Maybe you should try it. Okay, here it is. Okay, so as parameters, we have the SIP error code and the SIP reason from the MSRP side, call that fails, and we can compose a SIP message, a separate SIP message to the client and tell him what the error was and what the reason was for the failure. Okay, maybe I should run this. Okay. Here. Oh. Okay, this is just for listening for that failure message. And if we, okay, so we reject it, and here you see the message: failed to establish session, 603 declined. So it's this one here. And yeah, I think that's basically it. Covers the most important aspects of the module.
How do you know the messages and the invite is in SRP? Do you have to test the mic type?
How do we know that the invite is MSRP?
Yeah, you're receiving an invite, but how do you know if it's voice or text?
Okay, you mean to answer it like here?
You know, but let's say it's the same routing also for regular calls. What will be the
Yeah, you should test for the SDP body.
Yeah, we have as a media type, it's message, TCP or TLS, MSRP. Yeah. Yeah, and yeah. Yeah, yeah, because MSRP is transported in the SDP of the SIP. Maybe you have, I don't know, voice too in the same session. Multiple media.
Nobody would be so sick.
Yeah, that's the idea of unified communications, to have voice and chat in the same session.
So if I noticed correctly, the SN graph is looking at each one of the messages like it's a different dialogue.
Yeah, because in SIP message there is no, I think there is even no call ID. Yeah, yeah, there is no call ID. Correct.
Yeah, there's nothing. It's just the back and just one transaction, like
Yeah.
back and forth of the message.
Exactly. Any other questions? Okay, then I don't know. Okay.
Complete client is a complete MSRP client or not?
Yeah, depends on what do you mean by complete.
Complete, for example, to send fax, not only message or voice.
Not sure. I think it has file sharing. I think that it's possible with MSRP. Okay, yeah, some with screen sharing.
But at the end of the day, that's completely transparent, let's say, from the MSRP perspective, because it's just, the payload which is sent can be whatever, can be binary, can be...
Yeah, any MIME content.
It's up to the client to know how to interpret the payload. Otherwise, the rest of the infrastructure, let's say the relay, is completely agnostic from the content perspective.
Yeah, you have the content type in the MSRP itself. So from SIP perspective, it's SDP with MSRP. Here we have the actual content type.
So in MSRP, you see the full path all the time, right?
Yeah, it's the path. It's first the relay.
So there's no hiding, there's no nothing. You see every hop by hop.
Yeah, but it's between the client and the relay. It should be TLS normally, but for simplicity's sake, I put it to TCP. But you have TLS between the client and the relay, and the relays between themselves, they may have a mutual TLS authentication, or they are usually trusted.
יפה, מלאה עכשיו.
One.
Space, final frontier. These are the voyages of the starship Enterprise. Its 5-year mission, to explore strange new worlds.
One more, yeah.
Okay.
Okay, guys, let's continue. And ladies, not girls, come on. Show some respect. Okay, so we will continue with the MSRP. This is, I'll try to explain what is the setup of the demo that I will have. On the top, we have a client, which is actually a SIP client, WebSocket embedded in a web page. Thanks to Razvan for putting together this small client. I think it's a PJ SIP or something in there. And we will be using as a client for the contact centers, is to simulate the clients for the contact centers. And this is able to generate only and send and receive only SIP message requests. So that's it. It's a very basic kind of client. The SIP messages, as we already know, will go into a first OpenSIPS instance, which will convert into an MSRP session. This all these calls with MSRP will hit our contact center, which, if there are no available agents, will hit kind of let's say queuing system. I put here the TOH, basically, let's say, trying to make an analogy with the MOH, the music on hold. This is call it text on hold. And here we have a very simple, again, OpenSIPS instance using the MSRP user agent module. And we do interact with through events and MI commands. Basically what we are doing, once we get a call, we will answer at the SIP level, and then interfacing through these events, OpenSIPS events and MI commands, we are interacting with an external script which is actually driving the conversation here. So we have some way of automatically generating SIP messages like, okay, welcome to the queue, you are on hold, and this will keep iterating through the ongoing sessions here in the queue, and every 5 seconds we'll just send a dummy message, hey, hold the line, we are still here, you are in the queue. So this simulates again the waiting queue for the contact center. We will see this is very simple actually as configuration in terms of what it's doing. It's just accepting any kind of incoming SIP calls. And then we have the script which is generating the text, the reply. So it will scan for the ongoing sessions, and it will from time to time generate messages. Now, if we have agents, the contact center will send the calls to the agents, which surprisingly are also OpenSIPS instances with the same kind of MSRP UA, user agent client. What these agents will do will automatically answer in terms of SIP, and then as sending back messages is first to generate like, okay, you are connected to an agent, kind of a message, and then for whatever the client types in, so sends here to the agent will mirror back. So it's a very dummy example. I had some ideas to try to hook it with some chatbot, here on the agent, but okay, there was not enough time for that. So it will just mirror back what you type. So basically, that's the, let's say, the simple kind of almost. You type something and the agent will reply, yes, I will think about blah blah whatever you already typed. So yeah, it's Echo plus plus. And again, in this shell, it's a Python script actually driving the behavior of the user agent. After 30 seconds of conversation, we'll just hang up, just to easily clear the sessions. So the flow is, we have the web page going from message to MSRP, contact center, and then agents. Basically, it's trying to replicate what you see on a lot of websites. You have this kind of, small chat windows where you can get help or you can ask questions, whatever, in regards to the services provided on that website. Of course, you don't have to go with the SIP all the way to the web. That's the simple way we did it. You may have from here, from the actual web application that you have, you can go only with API to something like an MSRP user agent. So you can just do some API call, remote API calls, and actually start the whole SIP and MSRP stuff using an OpenSIPS with the MSRP user agent. So that you can, let's say, cut all this part here.
Topology-wise, can we do MSRP direct in front of the web client?
Like to stretch the MSRP all the way? Yeah, sure. For us now, it was much simpler to get like a simple SIP message rather than doing, the whole invite, blah, blah stuff with. But yeah, so from topology or functionality perspective, it's the same. Yeah, there's no issue with that. Okay, so that's how the diagram works. For the sake of the demo, we're going to ignore this part, at least, this gateway, because we already saw from Vlad how it works. We will just have the web interface, and I will show you and walk through the configurations of these OpenSIPS instances. Even here, logically, I have like 1, 2, 3 MSRP user agent instances. In terms of actual implementation, there is only one, because all of them are actually user agents, so I can distinguish what kind of traffic I receive, like if it's targeting like what I have as a request URI, an agent, or the queue. So the script here, it's actually handling all the cases. So it's, in terms of implementation, actually, we will have just 2 instances. The actual contact center, and then the MSRP user agent doing the queuing and the agents. Okay, this is a bit more complex information, but just to show you the interaction between the OpenSIPS MSRP user agent and the Python script to understand how these events and management interface commands are used in order to, let's say, drive the behavior of the user agent. So everything starts from events, which we get whenever the MSRP UA, from SIP perspective, let's say, gets a new call. So when we have a new incoming call, you just accept the call from the script level. After that, the whole thing starts in terms of 200OK, doing the ACK, setting up the MSRP stream. So from the script perspective, it's something very simple. You just do like answer, call, bam. And then all the magic happens behind it. And when it's done, you get this event, MSRP session new. So basically, okay, a new MSRP session was established. So what I do, I'm using some database just to put some information and communicate. It's a it's an ugly way, but it was the simplest to understand and to follow. So in the script, if I receive traffic on port 5060, then I know that's it's a call for queuing. If it's 6070, it's a call simulating an agent. So I just, because it's a single instance, I'm using different ports on the OpenSIPS side in order to make the difference between the two cases. If it's a queue, it's a call for queue, so basically I put the call on hold in the queue. I have a simple custom table where I just write down the session ID. That's it. Basically, in this MSRP queue table, I just want to have the list of ongoing MSRP sessions that I have in the user agent. So when I have this session new, I just insert the session ID, and when I have the session end, which of course will be this event is triggered when a session ends, I just delete from the MSRP queue table. So basically, using these two events, I add and remove the session IDs from the table. So in the table, I have only what's ongoing at that very moment. On the other side, I have the Python script running, looping, looking into the database in the MSRP queue table and checks for the inserted records. If it's a new record, there is a second field with a timestamp, like when the insert was done. If that was not populated, okay, it means it's a new record, MSRP session that was just inserted by the user agent, and then fires an MI command back to OpenSIPS, sending for that session this welcome, you are in the queue, please hold on for an agent, blah, blah, kind of reply. If it's an older record, so it already has a timestamp, then it's just generating like a recurrent message like hold the line, just to be sure, just to have some kind of a feedback that you're actually something is happening over there and you're just like, sitting like a duck over there. And after each iteration, it's updating the timestamp of the record, so we know when the next hold the line should be generated. So it's very simple behavior. It hooks with these two events. Now, if there is an incoming session for an agent, I do something similar, writing down the session ID for the agents in a very similar table, the MSRP agents table. And I'm writing into, okay, that's not MI to send, sorry. It's writing into a table in the MSRP, so let me fix quickly. Ah, sure, okay, sorry, that's an image. The whole thing, it's an image. I cannot edit here. I did it in something else and then, yeah. Okay, so instead of this line here, what we do, we are just inserting a record into the MSRP messages. So basically, these are the messages we want to be sent by the script. So once I have a new agent basically connected, I put its session into the table, and also I'm adding in the table like a kind of a welcome message to be sent back to the customer saying now you are connected to the agent. So just something to realize that it's, the customer can start the conversation. So here it's actually, again, insert into the MSRP message table. For the ending, it's the same. More or less, if it's a session, we delete. So the same mechanism, using the session new and session end, just to see exactly, okay, what are the active calls targeting agents. And I'm also having here the third event, which is triggered whenever I received from the SIP side, so through MSRP, a new message. And I'm just, if the message is received through a so-called, let's say, agent session, so I just want to ignore the sessions on the queue. I don't want to reply for the queuing. That's why I have this kind of a if we're going to see in the actual script. So I take the received message, I put that, smart reply like I'm going to think about whatever, and I'm placing into the MSRP message table. Over here, for the agents, the only thing for the MSRP agents which is done is checking for the records older than 30 seconds, and if so, it sends first like a bye-bye message through like a MSRP message, and then it's terminating. So again, using the MI command, it's terminating the MSRP call from the agent side. So basically, we keep the call only for 30 seconds just for the sake of the demo. With whatever records we find in the MSRP message table, we just take them, and using the MI command, we instruct OpenSIPS to send that MSRP message to the back to the customer. So that's the, brief overview of the interfacing between the OpenSIPS side. So basically these three events, and what the script, the Python script, the external script does. Basically, of course, you can do whatever you can imagine, different kind of interaction, but the idea is you can have an external entity used to drive the behavior of the user agent. So, as I said, that's a very short presentation as slides. So, yeah, let's move to the real thing, to the OpenSIPS configuration. But first of all, are the fonts large enough for you to see all the way in the back? We can do a plus plus, costs nothing. It's okay? Or plus plus?
Yes, it's plus plus.
Yeah? Okay. Okay, much better? Right. Okay, so wow. So let's start with the configuration of the OpenSIPS contact center, sorry, because actually it's very, 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 very simple. So we will just go through. Okay. So in terms of the specifics of this configuration, we are just using the name of the module is still call center, but even after we have this contact, after having this MSRP support added, and even if, let's say, we handle messages, basically the module does call dispatching, to the agent, so it's not actually interacting with the MSRP layer more or less at all. So it does a lot of things in terms of resources to know, how many agents, how many chats ongoing they have, how many they can do, and so on. So it does all the management, but it's not checking at all into the actual MSRP flow. It's like with the audio the same. So when you use the module, the audio is flowing just directly between, let's say, customers and agent. Doesn't have to go through the actual module. So that's why you see actually we don't have anything related to the MSRP. So just the call center reading information from the database. And the behavior, okay, I'll skip. This is a generic, the generic part for any kind of OpenSIPS script with handling sequentials. And basically the important part is this one over here. That's it. So if I have a brand new invite, incoming invite, I'm just using the CC handle call. That's the name of the flow of the queue, so it's support in our case. And that's it. After that, the internals of the OpenSIPS will take over the call and see what has to do with it, sending to the, put it on hold if there are no available agents, or send to an agent, or whatever. But the idea is, from configuration, that's it. If we look, okay, with the control panel, we have configured here 2 agents for the contact. Okay, first let me show you actually the flow. Oh, sorry. So we have only one flow, the support one that we're using from the script. And in order to, let's say for the agents, in order to serve this flow, the flow requires the skill, the so-called support skill. And here we have the SIP URI for the so-called queuing. So whenever, okay, we need to put on hold calls targeting this support flow, but it sends the call to this request URI. So that's for the text on hold, basically here. And the agents, most important, we have the skill over here, the support skill. So that maps with the skill required by the flow. That makes the agents to receive the calls from that flow. So the skill is used to match agents with the flow. And what I have here, I have 2 SIP locations. This is actually used for the audio part. Okay, it will not be actually used here. It's optionally. And we also have an MSRP location. So basically, if you have an agent that may support both audio and MSRP, you can have from SIP perspective different locations. So maybe, okay, let's say have a SIP phone for audio, and maybe it has some, I don't know, embedded SIP client for chatting or something else. So it may be completely different. When using the MSRP location, you also have to specify how many simultaneous MSRP sessions or chats the agent can do. With audio, of course, it's only one all the time, but if you have MSRP, you have to state how many can do in the same time. So here we have like 2. So that's the provisioning of the module. So if we just do a query, an MI query here, to list the agents and the status of the agents that we have in the contact center, we have the 2, the 007 and 008 agents. Currently, they are not logged in. So basically, if we list, if we list the flows, we will see that there are no logged agents, because this guy, none of these guys supporting support are logged in. So basically, right now, the flow has no agent able to serve the call. Okay, this is a part for the contact center. Again, quite simple. Let's move and see the UA part, the MSRP user agent part. This is a bit more interesting in terms of scripting. For the SIP side, it's more or less the only thing for the call. So whatever it's not a call, I reject. And whenever I receive an invite, so brand new, in our case, MSRP call here, I'm using the MSRP UA answer. and I say that I support, from MSRP point of view, only text plain. So that's the MIME for the MSRP layer. And that's the magic, all the magic that you have to do basically in terms of SIP. So for simulating the agent and simulating the queue, so like an endpoint answering, you just call the function. OpenSIPS will take over after that the whole process of setting up the call and just do exit. And basically the interesting part is in the event routes, when we intercept, first we have the MSRP session new. So when we receive a new, when we have a new MSRP session established, as I said, we are listening on 2 SIP ports. So if I receive something on the 5060, that means it's for the queuing. So we simulate the queuing. And as said, I'm just inserting into MSRP queue the current session ID. So I just want to notify basically the external script that, okay, there is a new session. If is for call for an agent, we more or less do the same with into MSRP agents. I also insert a lifetime here, with that, which is actually the current timestamp plus 30. 30, that means, okay, I just want, after when this lifetime expires, I want to have the external script hanging up. So I'm just using this value here to say, okay, when the call should be terminated. And I insert actually the first message. So in the MSRP messages, I say, okay, for this session, please send this message, you are connected to live agent. So when the new session is established to an agent, the client will receive in the first place this kind of message. I use a cache, a local cache in OpenSIPS, just to remember which sessions are agents and which sessions are queue, because I want to know exactly when I destroy them, okay, from which table I need to remove, and also to process like replying to messages only for agents, not for the queue. I mean, even if you are in a queue, nobody prevents you from sending messages, so we don't want to, we want to discard whatever it's sent to a queued call. So I use this caching and storing the session ID, so that's the key. And if we look below, when we have the MSRP session end, I'm checking first in the cache to see, okay, is it a kind of an agent session or it's a queue session? And depending on which one, if it's queue, I remove the call from the database from here. Otherwise, I simply remove it just from the cache, saying, okay, that's terminated. The external script will take care of and removing it from the database. We'll see. And if we receive a message, so the event about incoming message, I'm taking care only of messages received for the agents sessions. So I do a cache fetch to be sure that the current session is mapped to an agent. And if so, I'm just taking whatever was received, this param body, so that's the body of the message, and I'm inserting into the MSRP message table this with, I will think of this, whatever you type in. So this mirroring plus plus or echo plus plus was called, right? So that's basically the whole logic into the OpenSIPS. And let's see the Python script. So this will check basically what we'll do at each iteration. It will check the content of the 3 tables: the agents, the queue, and the messages table. First, you see selecting everything from the MSRP queue, and I'm looking only, let's say, to the so-called expired, because initially will be inserted with nothing, with no, sorry, without a timestamp. That will be by default 0, and I will check it here, and if it's the 0, it means it's a brand new session accepted. So I will use the OpenSIPS CLI. I was too lazy to do a REST query here, so I just do a sub process with the OpenSIPS CLI. Using MSRP UI send a message, so I'm to send the message to the current session, the row 0, it's the session ID. Text plain content, and then welcome to the demo service, blah blah, agents are busy, please wait. So that will be the message that we deliver on the spot whenever we put a call on hold. If the row, the timestamp, it's not 0, so there is something valid, meaning that, okay, the call was already accepted, we went through this welcome. In a similar way, I'm just sending something else, like doing our best, hold the line. So just a looping message, you know, to give the feeling that something happens. You're not sitting there for nothing. And at the end, I'm just updating the timestamp with current timestamp +5. So basically, I just want to be sure that the next iteration for this session will be in 5 seconds when, again, we will send this doing our best. So that's why when we select only if the timestamp is below the current time. So just to be sure that we are sending only once every 5 seconds. So that's for the queue sessions. We are done with this part. Now we move to the message table. And basically here it's very simple. It's just selecting everything from the table. And for each one is doing an MSRP UA send message and whatever was in the database. So it's consuming the database by sending everything back through the MI interface into OpenSIPS. And the last, the scanning also the MSRP agents table. I'm reading again only if the lifetime is higher, lower than Unix timestamp, and so it's not expired. And okay, here is sending this when the expiring happens. So we are sending this bye. So okay, it's done with the conversation. And after that, another command to OpenSIPS like MSRP UA end session. So we send the bye just, you know, to be a bit polite, and then we hang up. And you see we delete also the record from the agent, so is consumed. So basically that's the script. So I'm not going into the details of, you know, database stuff, but the logic, that's the logic over here. And normally this should be like a kind of a daemon, you know, continuously running. I was too lazy to do that, and thanks God we have the watch command. So actually we keep running the script instead of iterating inside the script. We are iterating the script itself. Something like this. So this one, it's every 1 second. It's checking all the tables and doing the actions for whatever happens. Okay, so we have all the things in place. Now, let's do, we have the pretty nice here web page with the client. Each time we access the client will automatically generate like a caller ID, like a account. This was like, okay, let's do some. It's client plus dot some random number, so we can use in the same time multiple tabs with pages, so with different agents. And now I can start typing. Before typing anything, let's look again to refresh about what we have in the call center. Basically, nobody is logged in, so I have no agents in here. So what should be the expected behavior now? Sorry? Yeah, so the call actually will be sent to the queue, which will say, yeah, welcome, please, well, agents are busy, blah, 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 and this kind of thing. So we already got this. And now, every 5 seconds, we will get doing our best, hold the line, and so on and so on. We can actually check here. Oops, sorry. We have an ongoing call. Okay, sorry, one. And also, if you see, in the queue, we also have this media MSRP. Basically, even if it's not taking care of the MSRP side, the module looks into the payload, so basically in the SDP, in order to see, okay, is it audio or actually RTP, not audio, so it's RTP or MSRP call. And depending on that, it will know what exactly to require from the agent. So it will look for agents able to provide this kind of media type. Okay, so now, this guy is still waiting over here. So let's log in an agent. So let's put the 007. We're going to log him. Oops. And now we got this, you are connected to live agent message. So the call center terminated the call to the queue and created a new call going to the actual UA, to the actual agent, sorry. And if we look here, we see we have state, it's in chat, so it's not free. And we have ongoing chats 1, free chats 1, because overall this agent can do 2 maximum chat sessions in the same time. So we have only 1 used, right? And just to see the interaction, let's say we type something here. Huh? Come on. Huh? What happened? Sorry? No, it was still running. Okay, let's check the database. Okay, there was nothing in it. There's nothing inserted. Mm-hmm. Oh. Okay. Let's redo. Let's from the gateway side, I will just close the now we have, okay, I hanged up from the client side. So, let's double check. Oops. Double check. So, okay. That's the magic solution. A restart will help, hopefully. Okay, script is running. Let's log out. No, to log out to get again. Yeah, to go again to the. Okay. And let's do a. Okay. And let's. Okie dokie.
I'm not connected.
What?
I'm connected now.
What do you mean?
Are you destroying his demo?
Yeah.
Okay. Well, the agent now it's.
Yeah.
Yeah, it works for me.
So we should see like 2 sessions. Oh yeah. Ongoing chats 2, 3 for this guy 0. And if I will let it like this for the 30 seconds, we will see that, okay, we get the bye-bye, and the session will be terminated. So, well, they are long, very, very long, 30 seconds. And after that, we can try the scenario with making the call while the agent is already logged in. In that case, we will not go to the queue. We'll go directly to the agent, and then we can check with having 2 agents, both agents logged in, and we have multiple calls. Then we will see, okay, they are distributed between the 2. Let's see. Okay, we still have this. This is still working. Wow, these are really, really long, 30 seconds.
I think something else happened.
Huh?
The session expired before being able to close it.
Oh,
See this? Sorry.
on the gateway? Dar să cine limitează? Nu, asta ca ce e gateway sau cine e?
Da. Nu, eu am scuze. Și nu știu de ce limitează la 30, dar de ce zice că nu mai poate să mai trimite probabil astea zbaiurile și nu le-a trimis.
Nu știu, mai.
Nu înțeleg de ce
Nu știu dacă...
nu știu.
Okay, there is an early timeout. Actually, the sessions are destroyed in the user agent. That's why we don't get the buying here in termination.
Can you try lower the timeout?
Yeah, sure. That's an easy one. But first, I'll have to kill the sessions from the gateway side just to have a proper, cleanup for the calls. Okay, it's free, and we can do, okay, here, we can do only 10 seconds, let's say. Let's see. Okay. And now let's start a new agent. Okay, hold on. Let's see what the status of the. Okay, so if we try now, we will go directly. We go directly to an agent because we have an agent logged in. So let's also do this. Boom. So that's and we check if we check on we see that the call was terminated, so there is no ongoing. And also if I check on the gateway, so actually the call was cleared completely, the MSRP call. Okay, and we have time, so we can try to put the 008 agent also. So now if we look, we have two free agents, both with, okay, they have both of them two sessions, two free available chat session in parallel. So we can create multiple tabs. So, sorry?
At least 5 to overload your agents.
Okay. Okay, you will do the 5th. So for the moment, let me start the. Okay, so sure. So we have so far 2. We have 1 and 1. You see, each agent got 1 call.
I was assigned an agent.
Sir?
I was assigned an agent.
Oh, okay. So that's the 5th went to the queue. So if we look now, both agents have. Okay, probably I think some for this one already ended because it's the 10 seconds. Yeah, we have this with already cleared, and this one okay. I was too slow in doing, but now the one you see with the demo on the queue was already sent to a live agent. So if we check the previous ones, that was terminated, and this one was for a bit in the queue and then sent to the agent.
Mine is terminated as well.
Sorry?
Mine is terminated as well.
Yeah, we still have the last one, which I'm not sure why it's not. Oh, okay.
It's not this one, it's the one that...
Yeah, okay. The thing with the byte still, okay, issuing. So there is a timeout somewhere. But you got the point, right? Yeah. So, okay, let me. Oh, okay, it died to a point. So yeah, that's the whole idea with the call center. And again, keep in mind that agents may be mixed. So you can define an agent which may do calls or chats. Of course, at a certain moment, it will do either chats, either calls. So you cannot do both in the same time. But you have this kind of a mixed agents. For the calls, all the time there will be only one slot available. For chats, you can define how many the agent can do in parallel. I still have a bit of a logical issue with wrap-up time when you do chat, because basically it's not like when you do like multiple, you have different timestamps for terminating. So theoretically, you should keep like a wrap-up time for each channel of potential channel of MSRP, but that would complicate things quite a lot in how the call center right now module its structure. So for the moment, we are keep piling the wrap-up time in a single value, reflecting all of them for the all possible chats. Okay, if you have questions before, I would like to show something else. Yeah.
So I saw that at the end of each MSRP session, there's this E and like a message about that notifies the end of the session. And this is when you're deleting the session from the queue table, right? That means, if I understood correctly, that the session still exists in the queue table while answered and discussed and communicating already with the agent. So
Hold on, you mean when you send this bye-bye stuff, or?
So the bye-bye that terminates.
Yeah.
Is that when the session is deleted from the queue table?
No. That's for the calls already connected to an agent. So the call, it's not in the queue anymore. The bye-bye is for the calls to, right now the queue lasts forever. So it will not kick you out of the queue.
The call center doesn't use the database for the queue, right? The call center
Yeah, no, that's just for to communicate to the Python script. So the bye-bye is sent only to the calls with agents or already connected to the agent, and it's first sending that bye-bye, and then it's terminating, let's say, from the agent side, the call, so it will go all the way through. Okay. It will go all the way, so it's terminated here, and then termination will go all the way to the gateway. Because the actual call, it's only from here to here. This last leg here, it's just SIP message, so it's not MSRP. It's the SIP message.
There is an event for the MSRP for agent answering, like, because there is on the new and
That's okay. The answering has nothing to do, let's say, agent concept with the MSRP. So the events we saw, they are strictly related to MSRP, and we had them here in the user agent. So, but if you want to get events related to, to the logic of the call center, you should go here in the call center, and the call center exposes events which are not necessarily related to the MSRP. It's an event each time a call is delivered to an agent and stuff like that. But so they're a bit different things. One, it's the MSRP layer, and we are using here just to simulate an endpoint, an MSRP endpoint, either agent, either queue. But call center events are here about call in a queue, call to an agent, things like this. Other questions?
Regarding the call center module, is there a way to partition the call center module from each event?
Directly, no. There is no built-in support for something like that, but in terms of how you provision your data, you could do like to create, let's say, basically partition the namespace of the skills and the flows, So there is basically no conflict between the queues, the flows, and the and how the calls are distributed between different tenants. Because an agent will receive calls only based on the skill. So if you have a skill which is uniquely defined to a flow that it's used only by a tenant, then those agents will receive only calls for, related to that tenant. But otherwise, yeah, there is nothing built in, like, partitioning. Yeah.
When an agent is typing, the session timeout is renewed or not? When he's typing.
So when the agent is typing, okay, those 10, 30, initially 30 and then 20 seconds lifetime for the connection were just to have, an automatic way and nice way to hang up. Normally that's an action driven by the actual agent, like pressing the button. So definitely, I hope the agent is not stupid enough to hang up while he is typing. So there is no in the module itself. We are just forcing, for the sake of the demo, to simulate some kind of real agent, which to a certain point is hanging up. But otherwise, maybe what you say may happen at the gateway level, because the gateway has no idea about the agent, and may, let's say, terminate this mapping between the SIP message and the session because of no activity, while maybe this guy's preparing the response. But, well, yeah, I mean, in real life, you should not have such a huge gap, like, okay, I will give you a reply after, like, I don't know, let's say 30 seconds or 1 minute, and in the same time, maybe you put a more reasonable timeout here, before flashing the session. The mapping, actually. Okay? Okay. We still have like 4 minutes and a half. No, 3 minutes and a half. And I just want to quickly show you. It's not yet, I mean, it's public, but nobody knows about it because, okay, there was no announcement, no nothing. And we are a bit proud of some work on the latest version of the control panel. We just released some version a couple of months ago. Still, we continue adding some new cool stuff, and I really want to go like 3 minutes just to show you, just to have an idea of what we did. Yeah.
Take time, because it's not so.
You're 60 minutes, man.
To feel.
Yes, to suffer. Okay, so first of them, okay, let me. While login, as you see, we added the two-factor authentication support for the login, so you can use the Google Authenticator in the control panel. So so let me see which one is. And as you see, we have a dashboard for the control panel with a bunch of widgets that you can play with. I mean, this whole thing is dynamic. You can drag, drop, whatever. So you can arrange. You can create your own. Come on, go back in line. Ah. You can create your own. Dashboard. You can have multiple panels, so it's not only one. And it's up to you, like adding what exactly you want to see, like about information about. Okay, let me try to do a plus. Different information about memory usage, CPU usage, users, dispatching. So let's actually see some. Oh, this one got on top. Like we have share memory usage. It's configurable, like what are the thresholds for saying, okay, that's the threshold for warning or critical value in terms of memory usage. You see actually these values, like when it will go yellow, when it goes red, so up to your system. If certain values are, let's say, going into the critical or Warning area, you see there is a kind of alarm button sign here that turns, normally it's green, but it goes like orange or red, like, okay, this is the private memory, the PKG memory, and it gives you the top only in terms of processes, just to have an idea, okay, about the worst situation. We have, okay, they overlap now because I just zoomed in. I will have to rearrange on the page. But you have information about the load with the possibility to, to zoom in the chart directly here. Charts are real-time updated, so if you leave the page, they'll be, you'll get more values. Also about the active calls things, or like if you use Monit, let's rearrange a bit just to be visible. So this one will give you like how many services are monitored through the Monit application, and it tells you, okay, running, unmonitored, or if you have some problems, registrations. Where was the active call? Okay, we have this is the dynamic routing. It's still work in progress a bit, some of them. But the idea it tells you, okay, we have 8 destinations, gives you information about, okay, if some of them are pinging mode or something like this. So you can quickly check if there is any kind of problem. And, okay, CPU, that's actually the real CPU on the machine. It's taken through Monit API, so it gives you an idea of what's going on over there. So yeah, that's we have a bunch of these. Oh, look, similar like for the dynamic routing, it's this dispatching. It says available 3 destinations, 1 it's inactive, and it's red. It's not like green in the dynamic routing where everything it's okay. What else? Okay, that was the load. Yeah, so that's pretty much the thing with the dashboard that we are working on for quite a while. And let's see if I have it here. Yeah, for the, probably it's too small for you to see it, status report. So now you can check statuses and the reports through the web interface. For example, okay, there are no reports here. Okay, like dynamic routing, we see the date, like starting, loading data, if anything happened, or let's say core. We have when OpenSIPS started and when the initialization was completed, or do we have anything? Whoa, okay, that's the pike, flood detection. We have a bunch of reports here you see, about different kind of IPs being detected as, yeah. So now you can check all these through the control panel also. So yeah, I just I wanted a bit to cover this part because somehow there was nothing addressing this, and I said, okay, I'm gonna take a bit of a time from Giovanni. Sorry?
Show the tracer.
Oh, tracer! Oh my God, where is it?
In the middle.
Okay. So you are familiar with the ability that you do use through the CLI. You can do like trace calls. So basically, instead of using as destination homer, so still capturing through HEP, but HEP is terminated into the CLI, into the OpenSIPS CLI, so you can see in the console, like if you want to quickly trace calls and the logs for the calls. Now you can do more or less the same with from the control panel. So instead of using the CLI, you can use the control panel as an endpoint. Razvan, because you wanted to show the demo, what do I have to put here? Put the Razvan? No? want something. What? Don't call me. Well. No? Tracing started, bind failed. Yep. I need to send a bug report. Looks like.
No, it's probably something misconfigured.
Yeah, but okay, it's not fully deployed, this part.
But you would have seen whatever the OpenSIPS CLI tracing command, trace command is showing, like the full zip messages for the entire dialog.
Okay. Sorry, this was not really prepared for the demo. It was just again something that we wanted to show because somehow we are a bit proud of all the work with the dashboard, and we said, okay, let's not miss the opportunity during the summit to show this work in progress.
Sooner or later, but kind of soon, it will be the capability to write the pcap files.
Don't push it. Don't push it.
I've heard.
Okay, so that's it. Thank you. So next we're going to have Giovanni to continue and show what he started on Tuesday and show us some IMS voodoo.
Please go have a coffee.
As a warning, and I'm really serious. During the demo, I advise you to shut down your phones because he will try to hijack everyone's phones here, the SIM card. So you better keep your phone completely shut down,
And
okay?
a tin hat, a tin foil hat.
Some metal underwear.
Yeah. A tin foil underwear. Yeah, we'll take some. Please take a coffee because I have to arrange physical things. slowly and steady. Something wrong. Review. No, we can begin if you tell the people. Maybe it's to the coffee. Good. One, two, three. Okay. Without further ado, I'll try to introduce a short and easy demo. So just to see what we were talking 2 days ago about how you can have, let's say, a complete end-to-end from the SIM to the voicemail 4G, 5G system in your lab, where you can develop your own applications that will then run as application servers that will connect to the IMS or the carrier or the MVNO. I do just a short hint that your let's say your aim is to develop additional services and application servers, not to replicate the entire carrier stack. So you're actually not interested into running an access radio, and you are not interested into running the 5G, 4G core that manage the access to the radio. And you are also not particularly interested into running an IMS core, because IMS core is probably already there, maybe from Huawei, from ZTE, whatever, into the carrier, into the MVNO that you are selling to. And you are selling, you are integrating additional services, application servers, whatever. They will not probably be happy with you tampering with their IMS core. Probably you will not even be able to enter that room. But you want to complement their services, or you want your services to be accessible with the latency and with the native power of LTE 5G. So
not going over the top through the internet, through a smartphone application or whatever, but be actually in the core of the smartphone. And so we have here the terminals, then ENB and GNB. ENB is the 4G LTE, GNB is the 5G radio access. And then on the right, you have the core network. In this slide, that is a slide from radio access people, their idea of core network is the one that manage the radio access. So in our case, the core network of this slide will be Open5GS. This is the the tower, a small tower. And Open5GS will manage all, let's say, the back office of the radio access. And is the part on top, while the part on down there is SSRAN. Then you have the IMS core. Please remember, in our case, voice, video, and whatever is just an application that is running on a TCP/IP network. It just happened to be directly accessed from the phone. So actually, two phones that calls each other, they will go to the radio, into the IMS core, and then RTP will flow kind of directly between them. So the latency that you can achieve is just incredible. It can be under 1 millisecond or things like that. And you see that, definitely. You see that in video calls, you see it. It's immediate and it's actually performing. One thing that we were discussing yesterday and today with many of us is that probably, I mean, we are maybe not businessmen, we have not probably that kind of eye for innovative products, but with that kind of latency, with that kind of bandwidth, you really can do, for example, some additional services that will do augmented reality through video into something, and that someone with some imagination probably will find a lot of market niches where you can add value with that kind of a real-time performance that, I mean, is just astonishing. And this is the smallest possible idea of an IMS core. And so basically is a proxy, a SIP proxy with a database, and an exploded SIP proxy. Because you always must think in terms of you are Vodafone. So almost billions of users and so many machines. So the general idea of how IMS works is the call or the terminal connect to the PCSCF, so the proxy CFCF. The proxy CFCF are just some security and first contact with the user, and the PCSCF will be in contact with the ICSCF. That means, so the proxy will be in contact with the interrogating CSCF. And the interrogating CSCF, the only thing that will do is tell the proxy to send the signaling to one of the 10,000 SCSCF, so the serving CSCF. More or less, all the real in our mind functionalities are into the SCSCF. The other two, one is, let's say, the front end, and the other one is just a redirection that tell which serving is to be used. At that point, the call, the dialogue continues in that way. So pass through the proxy to the interrogating, then the serving. Then do whatever is supposed to do. Probably in most cases, when one call another, it will just do the reverse path, and we pass back to reach the other user. Almost in any case, in a real carrier, will be from the serving, will go to the interrogating, and with any probability will go to a different proxy, because maybe it's another cell, another region, or another maybe even state. And in our case, obviously not. We have one copy of each one. And okay, that's just, and the HSS, you can think like a database with a lot of things. So let's say user profile, the subscription, the user location, and many other things that are defining all things that are related with the user, with the and that's one part of the HSS that we will see. And the other part of the HSS that impact on us, maybe more, is all the part that has to do with the application servers and with all those things that are called IFC, so initial filter criteria. And you can think at them kind of, they are the dial plan. So if a call is not for another registered terminal, what to do with this call. And that is, we saw in 2 days ago, that is described through some regular expressions that are the filters, so the initial filter criteria, and then you can see to what that regex apply, if to the session, to the dialogue, to the message, etc., and then what to do. This what to do often end up in being a destination. That destination is always a destination into an application server that is external to the IMS core, even if it is an application server that is internal to the carrier, but is not part of the IMS core. And any kind of service is an application server and is out from the IMS core. The IMS core is only this one, and many other things similar to this one, but has nothing to do with applications. And then when the filter criteria has been triggered, then the call will go to the destination that has been defined into HSS into that particular application server. Another thing that is interesting just for us, but also in the beginning, is we can define things not only for invites, so for call, not only for let's use the methods like subscribe, etc., but even for register. So each time the IMS core receive a registration or do a registration operation, that can be also the refresh or the deregistration, I mean, is expired or whatever, then the IMS core will send a register with the relevant data to the application server if you have set up that. And the interesting thing is that you can program the HSS to tell the serving function, the SCSF, to put into the body of the register the whole body of the IMS register. So you will get a lot of interesting information, particularly if you ask them to put additional information in that body. Other things are, and we saw that as an application server, you can have the privilege, if they give you, to interrogate and to interact with the HSS, so with that kind of super database. And you will interact in a hyper specific way. There is a specific interface, a specific programming interface that is just for the application server, that is called the SH interface. I don't know why it's called like that, and I never saw written somewhere, but it's the SH interface. That is a diameter interface, so you will be able actually to do many things. Read information about a subscriber, write information about a subscriber, and let's say subscribe to information of a subscriber in a way that each time that profile is changing for whatever reason, the HSS will push information to you in real time. And that, for example, typical usage is when the credit is finished, you will be alerted or whatever. This is a view of in the orange part is, let's say, the part that is internal to the carrier with proxy, interrogating, serving, and media server and media gateway, while PCC and PCRF are the two ones that interact with the core 4G, 5G, in our case Open5GS, to tell if and when, for example, the credit expired, so that user can't even connect to the radio or whatever. In the gray part on top is us. So additional services that can be the application server or is not readable but is the presence related servers. We use as a base a Docker file made by Hellet that was working with Karsten up to some months ago. Now is working for SRS-defined solution that are more into the radio access, not so much into the IMS part, but so more into the core 4G, 5G. This is a network topology from the ENB that is on the extreme left. The ENB is the manager of the radio. Is the part that is closest to the radio and that directly command the radio. Then we have MME, SGV, PGV that are part of the core 4G, 5G network for authorization, credit, etc. And then most part of it, PCRF, particularly PCRF, are the Open5GS, so the core 4G, 5G network. Starting a little bit right from the center, there is the PCFCF, so the proxy CFCF, and all the part that is the IMS core, so RTP engine, Fraunhofer HSS, and the interrogating and the serving CSCF. What we want is to arrive to something like that. We have on the left the IMS, so the, let's say, the border of the carrier or the MVNO, and it will interact with our platform that gives our kind of services. So we programmed the SIM cards, put it into the smartphones, and this is the part that deals more closely with the SIM. Here you define the, let's say, the number that can be called, that is the MSI SDN, and you define the APN, so the access point, that has to be specific values for the quality of service and the bandwidth. That helps, no, that is mandatory, it's not helping, it's mandatory for making it work. Because the phone itself will refuse to work if the level of quality and the level of reservation of radio resources is not given to him. It will refuse to place the call. Then you do all the IMS subscription, private, public, etc. I will not go into details in that. You can receive the presentation, but more or less you create one internal identifier that will be the subscriber, and then you associate with it all the kind of number that can be called. So it can be maybe an SIP URI in E164, or it can be a TEL URI, maybe some short codes, etc., etc. The concept is that the subscriber is an identifier that you never use publicly, but then you associate all the various identifiers that you can actually call terminal to terminal or with services. And I have here a problem because this phone is, for some its own reason, refusing to connect. But it was connecting before, and we saw it then. And so I will do the demo with one only phone, and it will not be so nice, but we have no alternative. And so it will be like that, that they call each other, okay? But, and, so when the other phone, the phone that works, started, he has, first of all, he will connect to the SRS ENB. That is the one that actually accept him into the radio network. Radio network that then it becomes the TCP/IP network. This has nothing to do with IMS. You can have and probably in the world, in kind of a short time, 2-3 years, the most part of 5G networks will not have any kind of voice services at all. I mean, the real usage for 5G networks is for the industrial plant to do real time with very low latency control of robots, of sensors, and with the low latency with IoT, but with very low latency in an assembly line, etc., etc. So actually it will is pushed to be the substitute of fiber optics into dense situation where low latency is required. So let's go back to our things. While we are used to think that the cellular network is something for the voice and it gives you even the internet on top of it, with 5G is totally reversed. 5G is a TCP/IP network distributed via radio, and someone can put voice and video services on top of it. That is a data network, stop. The voice, video, etc., etc., is IMS. That is Internet Multimedia System. That was the original name. So, when that phone booted, first connected to the radio. From the radio into the internal 4G, 5G core that authorized, etc. Then it gave him a TCP/IP address and the possibility to break out and go to the real internet. I mean, I can connect to Google through the, and actually there is the full, you can achieve 50 megabit second or more if you put it in MIMO to have bandwidth, because it's incredibly fast. I mean, it can saturate your internet connection. And is made for that. So, in the case of a smartphone, there is on top of the internet things and the network things, there is also an application to do IMS and will connect to our IMS core. And it will do, first of all, it will do a register, and let's see the kind of register packet that it sends, and this is exactly how we are used to see it. By the way, that phone connect in TCP, if I remember correctly. No, it's even in UDP. And but the kind of recent phones, they only connect via IPsec. So the only way to see what is actually sent by the phone is to see it from inside, in this case, Camaleo, and sending out with HEP protocol to some HEP viewer, so you can see the original packet. In this case, we see that is exactly the normal register that we're always seeing. It has just this p-access network info as internal usage that let us know what is the cell ID into 3GPP. And you can see that is is very similar to the private identity identifier and to the subscription identifier that we then see here. And this, okay, actually this is the user part, and is the first three, the first four or three, or whatever, is made by the country code, the network code, and then the user identifier. In this case, is 001 is the network, the country, and then is the 0100 is the network code, then is padding, and then there is the identifier of the user. This is has its own formalities, so it's more or less made for you. And you can see here, this is mobile network code and mobile country code. So it was the opposite. Before is the network code, and then is the country code. And the other part of that is a little bit more complex than what we're used is the contact part, where there are many fields that are populated, but at the moment we kindly are not interested in. It can be in the future when we will do something more complex. And the register goes from the terminal, the phone, to the proxy, CSCF, to the interrogating CSCF, to the serving CSCF. The serving is the one that do the real work. The other two are like redirector and interface. 401 it challenge, and then it sends with the authorization the nonce, etc. And we see that the authorization is as a different, we're used to see as an algorithm MD5 like in HTTP. That is the original one in SIP. With mobile, the lowest possible is is that one that I can't pronounce, but that is because it's a very old phone, so very simple. Actually, today they use much advanced authorization and credentials, and also they start already from the beginning encrypted, etc., etc. Another part that is important, and this is added by the IMS core, by the various chameleon that are running, is which visited network. So in which network the smartphone is, and eventually from which network is coming. And this is important for, I mean, obvious reasons and etc. So this is the register, and is kind of, let's say, familiar to us. And no, and that's just a script key. Okay, fuck you. Other things that he do, the smartphone subscribe to himself to its own SIP alias, that actually is one of the public identity. And he subscribed to himself, so it can be alerted from the IMS core if something is regarding that identity, because maybe I have not make you pay attention, but this one is registering. I mean, the registration in itself is made on the subscriber identity, so that is similar to the private one, and that has a SIP URI, but is never used to be called. This is, let's say, the main thing, that is internal thing, and for each public identity, there will be a subscription, so both the IMS core and the terminal and the smartphone will be alerted if something regarding that URI happens. For example, if an invite is coming from someone to this URI, it will be sent to the correct terminal, even if that terminal has not registered as this URI, but has registered as the subscriber. But all the additional public identity will be able to receive calls. So, for example, short codes or whatever. Or maybe you are a subscriber of a special service where you are given an additional number, or etc., etc. There is a person that...
Do you register with the MSISDN?
I can't hear you.
Do you register with the MSISDN or with the IMSI? When your phone makes a registration,
Yeah.
what is used? Is it the IMSI or the MSISDN, which is assigned to the IMSI?
I probably don't understand.
Give it the mic. Give it the mic.
Oh my God, now I'm important. Basically about that registration, if you look there at the request URI, I cannot read it from here, but is it there the mobile phone number that you use or the IMSI number?
As I told, is identifier that is kind of similar to the private identity, and is the subscriber, let's say, identity. And that is then all the other are, let's say, aliases or additional identities that are public identities. So you actually have three concepts into IMS. One is the IMS subscriber, and the IMS subscriber has a private identity that is used to authorize and verify all the public identities. One of these public identities is very similar as a name to the private identity and to the subscriber identity, but you never use that publicly. You use all the other one that can be short or long, or the normal E164, etc., etc. Maybe I can make it bigger. Can you see like that? No, probably not. No. Okay. I will try for the last time to make this one to register too. And let's see what happens if I try to do a phone call to a number that is not registered. Okay. So we have received a regular invite, and 101 is the terminal, the smartphone, and we can see that this is a kind of completely understandable invite with just some additional headers, and most part of the IMS additional headers begins by P, so P dash something, and as opposed as the custom headers that usually is X dash something. And we see that we have the access network, the preferred identity we all have used. And this is the preferred services. If early media is supported or not. Those are, it seems that are stupid things. But for example, that P early media, if it's supported or not by the terminal, by the smartphone, determines if radio resources will be booked for this now. So just to receiving the audio of the courtesy, this number is not available. Nothing happen into 4G, 5G if radio has not been booked, reserved. I mean, it doesn't happen that you cannot hear the courtesy message back even in early media, because the bandwidth has been reserved and the latency has been reserved. Is just incredible. I mean, how much things are moving on the back end of this. And we see that the SDP, if you are familiar with SDP, is in this case totally known kind of SDP. It's just that is using some codec that we're not used to, AMR and AMR wideband. But for the rest is totally understandable. I mean, P-time, send, receive, etc., etc. And the invite pass by. Let me inculate. Unfortunately, has just crashed SN grep, and let's do it again. Okay. This time I will not try to change the fonts, and it goes from the terminal to the proxy, to the serving, to the interrogating. The interrogating, in this case, send back to the same serving, and then it goes back to the terminal. And let's see. This is sending the 100 trying, and then in this case, because the other one is not registered, we have a 404 not found, etc. But I have from before a saved pickup that we can look at it, and is even more interesting because it's a pickup of a video call. So okay. In this case, let's see. Okay. Let's use the other one that is cleaner. Okay. And here we will see a much more complex trace because it's a video call between two terminals, so it's obviously more complex than the one before. And let's see it. I don't know if you can see it, but and you see that here in SDP we have just audio at this moment. Then it goes to the PSCF, CSCF, etc., and then is arrived to the interrogating, and the interrogating will then send back to the serving because we have only one. At that okay. At that point, we have all the provisional ACK that serves. It's a little bit complex. I'll probably do something dedicated to it, but there is a mechanism that is part of the reservation of resources, and that has to be satisfied, and has to be satisfied at the level of caller. And you see here that here. And there is all the mechanism of the quality of service that has to be satisfied by the network. And when it is satisfied, then it can start to exchange the streaming. And in this case, we have a streaming that is AMR wideband and H.264 at 90,000 bit rate. And the interesting thing is that we have a complete end-to-end negotiation for both the, let's say, actual streaming and for the reservation of quality of service and so network resources. And now, let's say one less terminal. And now I'll be able to show you how to break out. So I'm not sure if you remember, I will show, that we have created an application server and an initial filter criterion. Okay. We have an application server in Cloud PBX in the network, and an initial filter criteria that will tell if this is for the internal one, but there is another that is if the number is 9999, send it to the voicemail of on the cloud PBX. And that will be our application server. that actually is an entire platform, but is seen by the IMS core as an application server, and is here. And problem is that the kind of network in this hotel it is filtering out SIP. So we will be able to reach the remote platform. The remote platform will try to send us back, but then retry sending because it's blocked, and we also retry sending. Yes, it's carrier net. Exactly, it's carrier grade net. And okay, I had no time to prepare a VPN to show things, but at least we will see that if okay, that is okay, is the real one. So this one is the one attached to the black one is the one attached to the radio. So terminal, a smartphone, radio here in the black one. The white one is the remote platform, is the proxy of the remote platform, so it will receive from outside and it will dispatch to a free switch inside, if it works. I'm using, yes, that yeah, but it's carrier net, it's carrier grade net, it does. Okay, so if I do 777, let's see with 999. If it's not one, it will be the other. Okay, and it was. So we have here and not here, so it's 777. Okay. And we see that we have the from the terminal to the proxy to the serving to outside. And we have here from the outside to the load balancer, let's say to the OpenSIPS, to the free switch, and then it tries to send it. And you can see that this is, let's say, the IMS invite, and is going to SIP 777 without, it doesn't have even a domain. And here we receive it the same. So actually we recognize that like it is a DID. So we match that that particular number with a context as a number. The interesting part is that fundamentally you will always receive numbers that are to the same domain. So because actually is the domain of IMS, the carrier domain. I mean, it's just numbering inside that. You don't have multi-domain into a carrier because it's their own numbers. And in this case, for example, we still have AMR wideband, and so we need to support it. And to support it, you need to add support to your application server, particularly, for example, both to Asterisk or FreeSwitch. They have no support for AMR, particularly AMR wideband. They have not at all, I believe, not completely sure. For AMR, they have pass-through support, but they cannot, let's say, do things on it. They can just move packets. But they cannot mix, cannot do anything that asks for decoding actually the codec. They can just shift the packets back and forth because it's a pass-through. But thanks to the work of Nick versus networking, now there is patches available to compile the AMR wideband and the normal as a full-fledged codec module for FreeSwitch, so it's able to do the full functionalities of FreeSwitch. I mean, conference server, let's say the most important things. Okay, and same thing for the video codec. Video codec mandatory support in 5G IMS is H.264. H.264 in some phone, for example, OnePlus 6 is broken. I mean, it doesn't work. And but that's a problem on the phone, and I just tell here because it so much of my time before I found a notice in the internet that is broken in the OnePlus 6T. But in all the other OnePlus, it works, and generally speaking, in any kind of, let's say, modern smartphone, let's say smartphone of the last couple of years, it works perfectly because one of the selling points of LTE and particularly then for 5G, but even plain LTE on 4G is the video call. The video call is not an app, but it's native. It's just a SIP video call with H.264 codec. And man, it's really fast. I mean, has native latency, native all, and it's kind of perfect. And it's inside the phone, the normal phone that you used to call the grocery. And so that, for example, then this is what happened when an invite is arrived and on our platform. Then there is OpenSIPS will do the publishing for dialogue, this, that, and all of them are services that we can give back to the rest of the IMS or to the rest of the enterprise network. I mean, the end results of all these kind of effort is let's recycle the stuff that we are doing in the last 10 years as additional services to MVNOs, IMS, carriers, etc., and to all the possible private networks that will come in the near future. And why you want to do that instead of going the normal way through the internet or through the normal TCP/IP as an application over the top, let's say the lean phone on your smartphone or all those things, because you will be probably, I mean, I don't like it, but I can see that bypassed or cut out, because to the end user, I mean, to the customer of the carrier or to your customer, they want seamlessly the call goes from the SNOM to the smartphone without passing through the internet, without the delay, without the latency, lower quality, whatever. No, it must be native. And this is the multiplayer thing of the MVNOs. They will be in the position to give services that span both the mobile terminal and the fixed terminal. You must be there to give them services and to show them that we can build on top of this, but more than this. Are you interested in that? It will, I mean, it takes effort, but it's possible. You know the drill, I mean, but I think that it's totally worth to start right now to prepare to put ourselves into that position, into the I mean practitioner, into the space of the experts that can deal both with the end user, with the let's say with the customer, and with the provider, because both of them will need us and our expertise, because providers has no people, and the people that has are too busy, I mean, with the core things, and they just don't have time, or, I mean, let's say organization to take care of someone that is not at the, okay, you're a Coca-Cola, okay, I will discuss with you. But if you are less than a multinational, you will probably not have a special thing built for you. But we can be the company of reference both for the customers and for the carriers and the MVNO. And we have the expertise to build all the complementary services that will go around the core offer, and that the custom services that the companies will require maybe for internal usage. So let's build a CRM that spans seamlessly with the contact center that we saw just 1 hour ago, and native at the level of 5G. Hey, come on. I mean, it has some selling point. And okay, that's it. And blinking lights, and it's nice. That was alpha now. You can't.
Any questions?
It's 1 hour and a half.
Ah, 1 hour? No.
Yeah, but he started 20 minutes late, so it's 1 hour and 10 minutes. No.
I was thinking that was
No, no, no.
My question is not a technical question, but a curiosity. Have you never tried to send an SMS?
Yes.
And in the SIP environment, what will be shown? What is showed in the SN grep in the SIP environment? It's not an invite, but is
I think that
message. Message.
see, yes, message. But I can show you because
So SMRP is
It's
also
on a curiosity.
SMS?
Yes. Well, not necessarily.
I don't think most
No, no, it's
providers
not for
didn't
SMS.
implement it yet, but
Yeah.
by the spec it is. It's for the future of 5G SMS.
It's for basically applications that require sessions at the messaging level. I believe so, yeah. I believe so. Let's see. Curious as well. Because, yeah, last time I've used something like this, it was SMPP.
SMPP, you will not see an SMPP.
Yes.
You will see an anger.
You sent a message?
so this is I will put bigger.
Oh, yeah, it's a message.
This is an SMS in IMS. In IMS, in 4G. In 4G, you think at 4G is, let's say, the bridge thing between the old way and the new way. The new way is 5G, and everything up to 3G is the old way. 4G is able to mix and match and is very complex, and 5G is much easier than 4G because 4G makes a lot of things for compatibility with 3G. It's very complex. 5G is much easier. So actually into IMS, into 4G, there are two ways to send SMS. One is the legacy way, like in 3G, and has nothing to do with the SIP. No. SMPP is with the SMS center. No, from the terminal. I mean, from the terminal to the network is something, but it's not SMPP. Is something that is part of 3G. And probably that guy, the French one, knows how it is. And but the new way is SIP. Is IMS and is using a message method that is get back just in 200 OK, so is not opening a dial, but is binary. The body is binary. So actually that it is. Mm-hmm. And actually, it was something like chow chow. It was obviously not binary. Yeah, and and in this case, a message center is Camilio, but and he's is not really working as SMS center, but there is a nice feature that if it do not immediately relay to the terminal, it will write into a MySQL table and then retry one time each minute to deliver it. That is like, I mean, a very light implementation of SMS center. But
obviously, I mean, the carrier has its weight, but the transport is that, is message, I mean, is message with the content type is not text, but is VND 3GPP.
Anyone? Any more questions?
So, so I'm assuming it's possible to use eSIMs. I wondered if I'm assuming it's possible to use eSIMs. I was wondering if you've tested that at all. eSIMs.
The one which we're discussing online.
Electronic SIM.
I have no idea. I presume yes.
Yeah.
But my very superficial, hyper superficial, and superstitious idea of eSIMs is you have a real SIM or something similar soldered into your device, and they use something, some signaling to interact in a crypted way with that soldered one, and then they exchange some additional info, so they can use that one to simulate more than one SIM. But at the end of the day, I mean, there are some parts that are related with crypto and with the private identity that are into that chip that are.
Yeah. Yeah.
In that case, it's soldered and you cannot exchange, and actually is just for the the provisioning is so much easier for them. They don't even aim to give you a chip, a material chip.
Yeah.
But it's for my understanding, all the rest is exactly the same. I mean, there is the hardware part inside the phone. It's just that you cannot change it.
Okay, great, thanks.
Any more questions? No? Oh, give cheers. Thank you, thank you.
So there is no plan for tonight. We are for sure going to go to the Plaka and guess what? Find a place that sells Uzo. That's right. So I guess we can get around 8, 9, 8, yeah, we can. I figure 8 will be good enough, so if anyone wants to join us, definitely do.
We need to announce, theoretically today is the last day because
5 of you.
officially it's the end of the shoot.
Okay. So if you don't mind staying for one more short 2 hours, a short summary. It is the not the training, and we're not going to be like in this large big form again. So first of all, before I hand out to you, I just want to say thank you very much for all, and it was really an amazing summit. So thank you all for participating, and lots of good. Let's hear the boss.
Thanks, Nitzan. Well, I hope everybody had a really good time meaning having fun, learning things, seeing again people, faces after like 2 years of staying apart. And I'm really glad I was personally able to see you all again and, hang out, having fun around here. I want to thanks to first to all the speakers we had, because they wanted to share some, you know, a good experience with you. Then thanks to the sponsors, because, you know, without them more or less the, you know, organizing everything would be not impossible, but very, 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 very tricky. And the last but not the least, to all the participants, because at the end of the day, you know, they are the people for we are doing everything for. So yeah, thank you everyone for this. And just stay tuned, because in the next probably 2 weeks, 3 weeks, we will decide where the next and when the next summit will take place, or the 2023 edition. We are still boiling some ideas. As Nitzan said, we need some, you know, some fuel for the evening in order to be able to process everything. So yeah, we will do our best in that direction.
Good. Sure. Excellent. Thank you very much.